Right, guys. If you're watching this today, we'll be looking at kinematics, area and volume, uh, construction, and something else, but I can't remember at the moment. So for kinematics, we'll be looking at the study of motion, and there are two types of graphs you need to look at: a distance time graph, which is also called a displacement time graph, and a speed time graph, which is also called a velocity time graph. Now, does anybody know the formula for speed? Speed is equal to what? And if you don't know
Distance over time.
exactly distance over time, distance over time. And let me just say, I ask you what's the formula for speed, and you say, well, sir, I don't know. I don't know what that is. You don't have any excuses, and I'm gonna show you why. Um, what is like when you're driving on the road, right? What does the gauge say? Or any highway, there'll be like you can't exceed 100 watts. A
Meters per
hundred,
second.
no, it'll be kilometers per hour. Well, let me ask you that question. What do we measure in kilometers?
Speed,
Distance?
sir.
Distance.
Oh,
And what do we measure in hours?
time.
Time. Therefore, the formula for speed is just distance over time. Bam. Now let me start off with distance time graph, right? That's the easiest one. Now for a distance time graph, you are going to have distance on the y-axis and time on the x-axis. So distance here, right? And time over here. Okay, right. Right now, Aaron, I want you to actually understand this, right? So Aaron, what does it look like we're doing here? Let me just say that that's a time of 0 seconds, right? And a distance of 0 seconds. This would meant that I started from rest. Started from rest. So Aaron, and if you start from rest, think of it. If I say you start from rest, and if you
Yeah,
start on something, the time is 0,
yeah.
and if you're starting, where's the speed?
0,
And where's the distance covered?
0.
Exactly. So 0, 0 is the starting position. Now, what does it look like you're doing as time increases?
You're covering more distance.
Exactly. And just seeing that because at a time of 0 seconds, the distance was 0. At a time of, say, more than 0, the distance increased. And as the more time that passes by, your distance is increasing,
Yeah,
right? Now, you need to understand that the gradient for a distance time graph will actually give you the speed of velocity, right? So gradient, right? So gradient for a distance time graph. All right. So guys, this is where students get like confused. So Aaron, do you understand that? Let me just say left somewhere, right? You're left somewhere.
yeah,
You understand that this will be distance moving away from that point.
yeah.
Okay. And this region here is flat. Do you think you're increasing your distance there?
No, sir, you'll keep at the same distance.
What do you guys think? Danelle, if the graph is flat over here, right? For any given time, my distance is remaining the same or it's increasing.
Remain the same, sir.
And you see now, like watch. At a time here, right? Same point. At a time here, same point. At a time here, same point. So over here, you'll be moving away. So moving away, I would say moving away from start. Over here, I would say not moving. Or in other words, stationary. You're on the same screen. Hmm. Yeah, let me know when you see the screen again. Wait, huh? It would seem that Zoom is giving trouble. Today's the last day for the year. I don't want. I like to see my crash out, you know.
I see it now, sir.
I say that again.
I seen it now.
You say now crash out.
No, no, no. I see it in the screen.
Okay, okay, wood. Right? So for this region here, I would say I'm not moving. Let me see how clever you guys are. What do you think I'm doing in this region? If this region was moving away from the start, what do you think I'm doing here?
You're going back down to restart, sir.
Way boy, Aaron boy. Yes, boy. Right? Because you realize you're decreasing in distance, right? Like as time increases, your distance approaches zero, yeah?
Yeah,
And if your distance approaches zero, that means you'll reach back where you started. That makes sense, right?
yeah, sir.
Yeah. So going back to start. Yeah, that's pretty much all you need to know for a distance time graph. You need to know that the horizontal line means you're not moving, right? This gradient here, a positive gradient means that you're moving away from the start. A negative gradient means that you're going back to the start. And if they ask you for speed, well, just find the gradient, right? Because we know that the gradient is just y2 minus y1. By the way, do we know what the gradient is? It's a good time to see if I remember the gradient. Do you all remember the gradient? Yes or no?
um y2 minus y1 over x2 minus x1.
Right. And to find the gradient, how much points you need?
2 points.
Exactly. Now let me ask a little question, right? And I'm gonna blow them mind here. What was the formula for speed? Run that back again.
Distance divided by time.
Distance divided by time. Now, boy, oh boy, I wonder where it have on the y-axis. So boy, I wonder where it have on the y-axis. Hmm. What have on the y-axis?
Distance.
Okay, so y2 minus y1 would represent a distance. And I wonder where it have on the x-axis.
The time, sir.
Yes, Aaron, you see why I say when you find the gradient for this, you find the speed?
Yeah.
Because it's y2 minus y1. What's on the y-axis? Distance.
The distance.
And x2 minus x1 was on the x-axis.
The
Time, distance
time.
over time, right? So this we need to know for our distance time graph. Take a screenshot.
I did, sir.
Okay, good. So let's look at velocity time graph now. Now again, the proper thing to say is a displacement time graph. Why? Because distance is technically a scalar quantity, right? There's no such thing as negative distance, right? It really is supposed to be displacement, but maths is treated the same. Just put it out there. If anybody doing physics, you'd know that displacement is the vector quantity for distance and could have both magnitude and direction. But you will see distance in a maths exam. And if you don't see distance, you will see displacement. Just keep that in mind. Okay, next one. Speed time graph. And this is also known as a, if you don't see speed, what else would you see?
Velocity, sir.
Yeah, if you don't see speed, you'll see velocity, right? Same thing, right? Same thing. In maths. In physics, no. Speed and velocity is not the same thing. Speed is a scalar quantity and vector is a, and velocity is a vector quantity. Right. So I'll put speed here. I give me a second. My laptop's taking too much to show like that. Right? Speed, time. Okay, and I'm gonna repeat the same process, right? Now, guys, are you all acquainted with the word acceleration? Do you all know what
Yeah, sir.
acceleration is?
Yes, sir.
Let me hear. What do you all think acceleration is?
Um, it's it refers to changing your speed, sir.
What do you all think? What if I tell you to accelerate? What would you do? Like if we in the
You're
car,
going
we drive,
up?
Go faster.
go faster, right? Right. So acceleration is just simply the change, the change in speed or velocity, right? With respect to the time taken. So let me give a little example, right? Let me just say I have this car here, right? And this car accelerates from 0 to 50 kilometers per hour in 5 seconds. And then I have another car that goes from 0 to 50 kilometers per hour in 10 seconds. Okay, which car would you say has greater acceleration? Let me hear, guys.
The second one, sir.
Okay, now guys, don't listen to don't just listen to what Aaron's saying. Give me your own opinion. What do you all think would accelerate faster? Accelerate at a greater rate?
30 seconds one.
No, the first one. The first one is
Because
going
it
to take
take
less
less
time.
time.
The first one is going to take less time to reach the higher speed. The second one now will take slower to reach the higher speed. Acceleration is really how fast you're changing your speed. Guys, look at this, right? Look at this. Which one is taking longer to increase the speed?
The second one.
Right, so would you say that accelerating at a greater rate or a slower rate?
A slower rate.
Right, because it's taking more time to accelerate. See, it makes sense, right? Aaron, you see why I was wrong?
Yeah, sir.
Yeah, so acceleration, people will just say acceleration is changing speed. No, it's changing speed with respect to the time taken. So watch this, right? Watch this. If I wanted to find the acceleration for this, right, I would find the change in speed. We went from 0 to 50, so what was the change in speed? It
50, sir.
was 50, right? And how long did it take to go from 0 to 50?
5 seconds.
5.
So the acceleration here was 10 kilometers per hour, which is 10 kilometers per hour squared. So let me try to understand what happening, right? So guys, essentially what happening, right, is every second that goes by, my speed is increasing by what? Let me see if I can
5
figure it.
5
seconds.
seconds.
10 kilometers per hour.
I thought you had 3 times, sir.
Now hear what I'm saying, right? Hear what I'm saying. For every second that goes by, my speed is increasing by
10 kilometers, sir.
exactly. That's what acceleration is, right? So for every second that goes by, my speed, I'm going to keep adding 10 kilometers per hour to my speed. So watch, in the first second, it would have jumped from 0 to 10 kilometers per hour. In the second, it would have jumped to what?
20.
Exactly. In my third second, it would have jumped to.
30.
30.
So all they understand that acceleration is just the rate of change of speed. It's how fast you change in your speed. Yeah?
Yes, sir.
Yeah, sir.
Okay, and over here now, the acceleration will be 50 over 10. So for every second that goes by here, right? For every second that goes by here, my speed is increasing by what? Over here now. For every second that goes by, my speed is increasing by
5.
exactly
5 kilometers.
right. And in 10 seconds, it would have increased to the 50. And that makes sense?
Yeah, sir.
Okay, good. So we just looked at what acceleration is, right? Now you need to understand that for a speed time graph or velocity time graph, the acceleration, right? The acceleration is given by the gradient. And why? Why? Why are we saying this? You'll see why shortly. Remember, what's the formula for gradient?
Y2 minus Y1 over X2 minus X1.
Right. I wonder, boy, wait up on the y-axis here.
Time. Or speed.
Speed
So we're really finding the change in speed. Uh-huh.
over time, so which is on the x-axis.
Which is acceleration, right? Hence, speed over time is acceleration. So everything makes
Yes, sir.
sense. Now, guys, in this region over here, right? It looks like I'm what? Like as time passes by, what is happening to my speed?
It's accelerating.
It's increasing or accelerating.
Right. My speed is increasing. So I would say that for this region over here, right? I am accelerating. So this is acceleration. Okay. For this region over here, am I increasing my speed? Decreasing
No,
my
it's
speed?
No,
constant.
it's stationary. So,
No, it's not stationary.
well, I mean, it's staying the same. So.
Right. So you have to say constant velocity, constant speed. So you could just say no acceleration, right? This is no acceleration. No acceleration. Right? And over here, guys, as time passes by, what is happening to my speed? Is it increasing or decreasing?
It's going back down, so it's decreasing.
Right. So you know what I would call that? What's the opposite of acceleration? Does anybody know?
Deceleration.
Yes. Is anybody confused by the concept?
No, so I
No,
get it.
sir.
Okay. Happy to hear that we understand the concept, right? So if you're increasing your speed with respect to time, that is acceleration. And to find the acceleration, you're going to find the gradient of the graph. Understand?
Yes, sir.
Acceleration would be a positive gradient, and deceleration would be a what gradient?
A negative gradient.
Right. And this gradient would be what? If you're not changing, right? And remaining the same, it should be zero. Just be zero.
Oh,
Yeah, because you're not accelerating, so you have zero acceleration. Any name, right? Zero, zero acceleration. Yeah. Over here, this would be a positive speed. This would be a speed of zero, and this would be a negative. You see, this is a problem. See, actually, there's your speed. It's supposed to be velocity. All right. This is a positive velocity. It's a velocity of zero, and it's a negative velocity. So, let me know if you understand the concepts of the graphs so far.
Yes, sir.
Okay. Well, you surely understand it. If it's have
Yes, sir.
anybody confused, I'll let
Yes, sir.
yes, I get it.
All right. Now, for a speed time graph, there's one thing you need to know. You need to figure out how to figure out distance traveled. How do you figure out distance traveled? If you have a speed time graph and you want to figure out distance traveled, you need to find the area under the graph. And you'll see why. It'll make so much sense. Distance traveled is just equal to the area under the graph. Area under the graph. So for those of you that don't know, area is just a product of two dimensions, right? Two dimensions. What dimensions do I have here?
Um, the the speed and time, sir.
Right, I have speed and time. Let's just say we're measuring speed in kilometers per hour, right? And let's just say we're measuring time in hours. If you multiply kilometers per hour by hour, what's going to happen?
Will become kilometers per hour square.
No, the hours will cancel off.
Oh.
I need to understand why you say hour squared. I need to understand why you say that.
No,
Because
I thought you said kilometers time. I mean, I mistake. I thought you said kilometers per hour times hours. Sir.
that's exactly what I said. That's exactly what I said. I
I
said
didn't. I didn't look at it like how it was on its like looking like a fraction. I thought you meant like kilometers per hour
Oh,
slash times, just how it is regularly.
I understand, but you're seeing now that it's kilometers all over hour multiplied by hour.
Yes, I see it
And
like
so
that. I understand. I get
the hour and the hour would cancel off, and that would leave us with what units?
just kilometers,
And guys, what does kilometers measure? It measures
the
what?
distance.
Exactly. Exactly. So if you want to find distance traveled, right, for a speed time graph, you need to find the area under the graph. And the most common type of area you need to figure out is the area of a trapezium. Most, because what? And that's all, you can see that this is a trapezium.
Yes, sir.
Right. So the main one you need to know is area of a trapezium. Area of a trapezium. And the area of a trapezium is just simply a half, right? Open bracket A plus B, close bracket by height, where A and B are just the parallel lengths and EH is the perpendicular height. Let me know if you guys understand this.
Yes, I get it.
And yeah, I feel like some of you guys didn't get it, so I'm just going to run it back one more time. I said the most common type of example you'll be looking at is the area of a trapezium, right? So I'm saying A and B, right? A and B are the parallel lengths. So I would say that this is A, right? And I would say that this is B. Is there anybody that's confused by me saying parallel lengths? Tell me now.
No,
No,
sir.
sir.
Or like, do you all
Yes, sir.
understand why I'm saying that they're parallel?
Yes, sir.
Okay.
Yes, sir.
And this is the height I'm
More
talking.
like and this is more like a physics question. Like,
Yeah, yeah. But funny enough, it don't really come in physics. It comes in maths and add maths,
oh, okay.
right? And in add maths, you actually model the equations with a variable t, and you differentiate and accelerate. I mean, you differentiate and you integrate to figure out what acceleration, displacement, velocity is. Yeah. I'm not sure if you do that in schools yet, did you?
If I do this in school,
Yeah.
yeah, I already had an idea of what to do.
Okay, would. Yeah, but this is the summary notes, right? Take a screenshot and we're gonna start past paper questions now. These are the most basic things you need to know. And when you have a screenshot, let me know.
Yes, sir.
Okay, would. Let me start off with a paper three question. They like to bring this in paper three. They overlove to bring this in paper three. Rare like to bring this in paper three. Right. So Aaron, there we go. Give that read from her.
Leela cycles along a path for 5 minutes. She
Wait there.
starts.
Wait there. Let me like after every sentence, I want you to pause and like soak it in, take it in deep. Right? So how long
Mhm.
did she cycle for?
5 minutes.
Let me underline that one time. She cycled for 5 minutes. Now, if you look at the axis, right, what does it have on the y-axis?
The speed, sir.
What does it have on the x-axis?
The time, sir.
But I'm measuring time in what?
Seconds.
So we think I should do that 5 minutes.
Put it on the speed, sir.
Mm, Not quite, right? They're giving us time here in minutes, but on the graph itself, time is in what?
Seconds. Oh, so you convert it to seconds.
Right. So 5 by how much seconds did I have in a minute?
60 seconds. It'll be 300 seconds.
Is there anybody that was confused as to why I did that?
No, sir.
Okay. Right. Yeah, let's continue, right, Iran? Then she does what?
She starts from the rest.
Right there? So she starts from rest. If you're starting from rest, right? Whenever you start, your time is initially what? Your time is
0.
right.
Zero.
And this is a speed time graph. What would your, if you're starting, right? What's your speed?
0.
Right. Okay, we understand now?
Yes, sir.
And then she does what?
She and accelerates at a constant um rate until she reaches a speed of 5 meters per second.
Right. Let me take that in, right? And it's in after 100 seconds. So in other words, how long did it take her to accelerate from 0 to 5 meters per second? How long did it take her to accelerate to that speed?
100 seconds, sir.
Does everybody understand that? Read it back and tell me if you
Yes,
understand.
sir.
So I am saying it took her 100 seconds to accelerate. She's starting from rest, right? So her initial speed would have been 0 meters per second. I think we could all understand that.
Yes, sir.
0, right? So from 0 meters per second. And she accelerated how? At a constant rate. If it's a constant rate, it's going to be a flat line, a diagonal line. It's going to be uniform y is equal to mx plus c, because we know that for a straight line, the gradient is the same at every single point. Now, let me show you how we're going to start graphing this thing based on the information we have so far. So we know that she started from rest, right? So you know what I'm going to do? I'm going to put on a point here at 0, 0, because she started from rest. Are they understand?
Mhm.
Yes, sir.
Yeah,
And how long did it take her to go from 0 to 5?
100 seconds, sir.
Right. So here, what we're going to do, right? What we're going to do? It took her how long? 100 seconds, right?
Yeah.
And she reached what?
She reached a speed of 5 meters per second once she finished 100 seconds.
Are you see any point?
Yes, sir.
Yes, sir.
Okay, good. I tell you, this topic not hard at all, man. I feel like this is another like quote unquote common sense. I want to use that word carefully.
Like vectors, sir.
Yeah, I feel like you could actually make sense of this topic. It's not like some topics like they're very far-fetched. I feel like you could make sense of it. You know? So like this region over here, she was what? If she's increasing her speed with respect to time, you'll say that she's what?
Accelerating.
Right, accelerating. Right? And let's continue. So what are they saying now?
She continues cycling at 5 meters per second for 2 minutes and 40 seconds.
Aha. So she did what? She what?
She was in a constant rate of at 5 minutes and 5 meters per second for 2 minutes and 40 seconds. So,
So guys, for the 2 minutes and 40 seconds, did she ever change her speed?
no, sir.
No, she did not. So how does that gradient look like? Would it look like this, this, or this? 1, 2, or 3?
It will be 2, sir.
Yes. Yes. And we need to figure out the time period for which she kept that same speed. Now, guys, am I working with minutes here? Am I working with minutes?
No, sir, you're working with seconds.
So 2 minutes is how much seconds?
120,
Right? And if you add that to 40, how much seconds did she stay?
160.
Right. Is there anybody that's confused by that?
No, sir.
Right. So guys, she took 100 seconds to accelerate. And now after she accelerated, she decided to stay at that speed, right? For a period of
Mhm.
160 seconds. So when should I stop next?
At one um
Timer. So she already traveled for 100 seconds, right? And on top of that, they're saying she kept at that
and
for 2 minutes and 40 seconds. So where do you think my next point is?
260, sir.
Yes, 260. Is there anybody that can't understand why that is? So does everybody understand that, she kept at 5 meters per second for 2 minutes and 40 seconds, which is equivalent to 160 seconds. So I just added 160 to 100 to figure out where that would be. Some of you confused.
No, sir, I get it.
This will be my other point. Guys, are you all sure you understand this?
Yes, sir.
Yes, sir.
Danelle, what about you? Gills, what about you guys? I said Gills, what about you guys?
Yes, sir.
All right, good. And then what's she doing?
Then she decelerates at a constant rate until she stops
Right. How long did she cycle for?
300 seconds or 5 minutes.
So our line needs to start from here and go to what time?
300, sir.
That is all. That is all. This was easy, right?
Yes, sir.
Easy 3 marks. What do you think about this? Easy or hard?
Easy, sir.
Easy, sir.
Easy.
Now I see, right? So over here, this is going to be no acceleration. And this period over here, what am I going to call that?
Deceleration, sir.
All right, so let me just call this acceleration, just to keep it consistent. Awesome. So I trust that everybody understands this, yes or no? I'm gonna just,
Yes, sir.
okay, good, good. All right, so in part 2, they want us to determine Layla's acceleration. Guys, what did I tell you about, how did I tell you that you could find acceleration for a speed time graph by finding what?
Gradient.
Divided by time.
Right, now you need to find 2 points along the line. What are the 2 easiest points to pick from that line? Oh,
5
well,
and 100, sir.
you mean 100,5?
Yeah, sorry, sir.
Right. Now, guys, a mistake students would make is they might pick points from here and all kind of thing. But this is asking us for her acceleration. So how you gonna pick any points other than by the acceleration, right? You need to pick points along this line. Are you understand that?
Yes, sir.
Yes, sir.
Right. So, some of you guys told me to pick 100,5. Nice. And there's a very, very easy point you can pick. Extremely easy. So easy, it's crazy.
Is it 84, sir?
Yeah, I mean, you could pick that, right? But I was talking about 0, 0.
Oh,
Because and she started at rest.
yeah.
Yeah, 0, 0. But truth be told, you could have picked any point along this line. I have a bunch of nice points, right? I have plenty nice points. Like
But
4.
once it's along the acceleration line, you could pick it, sir.
Yeah, once it's along the acceleration line, you could pick it. Understand?
Yes, sir.
So if I use 100,5 and I use 0, 0, let's just call this the second point, right? So I could call this x2, y2. Let's just call this the first point. It doesn't matter which one I call the first and second, you'll get the same answer, right? So her acceleration would be given by the gradient, right?
100. Sorry. Yeah, 5 minus 0 and 100 minus 0.
Or what would you get?
5 over 100, sir.
Which is
1 over 20.
and Thomas or decimal. If you get Thomas or decimal, Thomas.
0.2, sir.
0.2 or 0.02.
Let me double check.
0.05.
Oh,
Yeah, and an easy way to figure this out, right? If you have 5 over 100, right? You divide them by
yeah, I
100.
got it. Is there? I got it.
So 1, 2. Yeah. 0.05, and that would be meters per second squared. That's the units for acceleration. Now, if you don't understand that, let me show you something, right? So what are we measuring on the y-axis?
Speed.
Speed.
And like the units for speed here is meters per second, right? Now this really means meters over second. And we understand why, because speed is distance, meters, time, seconds, distance over time. So y2 minus y1 is really meters over seconds. And we are dividing that by what? What is on the x-axis? What is the units for the x-axis?
Seconds.
Seconds, right? So watch this. I have meters over second, and I'm dividing that by seconds, which is the same thing as s over 1. So guys, when you're changing division to multiplication, what do you do with the fraction? This is division. When you change division to multiplication, what do you do with fraction?
You flip it to
So that s over 1 is going to turn to 1 over s, right?
mhm,
M by 1.
M,
What's s by s?
S squared.
Right. So hence I'm saying meters per second squared. Understand?
Yes, sir.
No, that was the way you could have do it using the gradient method, but there was an easier way to do it, right? Using the physics approach, just the physics approach, right? So uh, acceleration, there's another way you could have do it, but I get full marks. I mean, it's just 1 mark, right? Write this down, right? So acceleration is just a change in speed. Change in speed. Again, really supposed to be velocity, but we're doing maths, not physics, so they are using it interchangeably. Change in speed over time taken, right? So guys, if we started from rest and we reached 5 meters per second, what was our change in speed? If you started at rest from 0 and it went up to 5, what was the change in speed?
5, sir.
Yeah, 5, because it increased the speed by 5. And what was the time taken to do that? How long?
100,
Yeah,
100 seconds.
right. And you would get your answer 0.05. Yeah. Is everybody okay with this question? Let me know.
Yes, sir.
Yes, sir.
Okay, good. All right. So guys, now they want us to figure out the average speed for the entire journey. Now, could somebody just remind me what the formula for speed is? And by the way, the formula for,
Distance divided by time, sir.
this is not the formula for speed, eh? This is not the formula for speed. Don't go and draw a picture I show in the exam. Now, if I was marking it, people would get I'm marking it, but I think so. Yeah, but speed is equal to distance over time, yeah?
Yes, sir.
So if speed is equal to distance over time, right? Then the average speed would be equal to the total distance traveled divided by the what?
Total time taken, sir.
Exactly. Do we already know the total time it took us to cycle?
Yes, sir.
The only thing we don't know is the total distance traveled. Guys, remind me, how would you figure out distance traveled for a speed time graph? For us,
The area under the graph, sir.
right. And I told you all that the most common one is the area for
Trapezium.
exactly. And what shape is this?
A trapezium.
Exactly. Exactly right. So to figure out the area for trapezium, you would need to know your top dimension and your bottom dimension. We already know that dimension will be 160. Because then she stayed at 5 meters per second for 160 seconds.
Yes, sir.
right? And what would the bottom dimension be?
300.
300, right? Nice. And what would the height be?
5.
5. Look at this, guys. Is there anybody that does not understand how I came up with these dimensions? Yes or no?
No, sir, I see it.
No, sir.
All right. So, guys, put all of that together. What would the distance traveled be? So remember, distance traveled is just simply area on that graph, right? So you're going to write distance traveled, and that would be equal to a half, right? Write down the formula first, half a plus b by height. So I'll tell me what to put into the formula. What's
160 plus 300 times 5, sir, over a half. Yeah.
Is there anybody that did not understand how I got the values for the formula?
Yes, sir, a little confused.
All right. So for a speed time graph, remind me, how would you find distance traveled?
Distance over time, sir.
No. If you have a speed time graph, you need to find the area under the graph. So tell me, what kind of shape is the graph?
A trapezium.
So what we need to do is we need to figure out the area of the trapezium, and that would tell us the distance traveled. And why do we care for the distance? Well, they asked us for the average speed, right? Now, average speed is the total distance traveled over the total time. So we need to figure out the total distance traveled. And remind me, how do you find the distance traveled for a speed time graph? By finding the
Area under, sir.
right, and the shape is a
Trapezium.
right. Now to find the area of a trapezium, let me just run that back one more time, right? To find the area of a trapezium, you need the height. This is the height dimension. This is the height, right? You see this dimension over here?
Yes, sir.
That is A. And you see this dimension over here? That's B. So to find the area of a trapezium, it is a half open bracket A plus B multiplied by the height. Is that clear?
Yes, sir.
So you just told me that this is a trapezium, right? So now we need to figure out what the dimensions are. First things first, what does it look like the height is? Some of that part confusing you.
Yes, sir.
All right, let me just clear the screen real quick. So can you see that that is 5, right?
Yes, sir.
So what would the distance from here to here be?
Um,
Don't overthink it. Watch.
5, sir.
Yeah, 5. That's it. 5.
Oh, okay, okay.
Right? And we need to know the bottom dimension now, B. What does that dimension look like?
300.
Yep. Right? What does the so okay, I have a question, right? If this over here is 100 and this over here is 260, what would this be?
160, sir.
Yep. So how would I find the area now? Which is actually distance traveled.
By half. Open bracket A plus B. Close bracket by height, sir.
Right? Now what is A and what is B? So it's gonna be a half of open bracket was A. So look at this and look at this. What is A?
Oh, that's it.
So 160. A is the top dimension.
Oh, okay.
What is B?
300, sir.
Right? And what is the height?
5.
5.
Right? So all you need to do for me is just plug that into the calculator and let me know what you get for the value. And that will tell you the distance traveled.
So I got 1,150.
Rest of you guys, let me know if you also got that. Anybody with anybody with a sharp having a hard time doing this? Tell me. Let me know what's going on, guys. I'm not hearing much answers.
I hear 1,150.
1,150.
Yes, sir.
Yeah.
Right. And guys, look at the dimensions, right? This dimension is meters per second. Meters per second. Area is just the product of two dimensions, right? So if that dimension is meters per second and this dimension is seconds, what we're gonna have only seconds there?
Will get squared.
No, cancel off. Wait, and I really need to clear up that confusion because like everybody confused by that. Guys, where is the second? It's in the numerator or the denominator?
Numerator, sir.
It's the denominator, sir.
No, numerator. What? Because it's S, it's not 1 over S, it's S. It's S.
No.
It's S. Right? Watch this. Okay, but even simpler way to explain it. Over here, I'm dividing M by what?
By S.
I know, and I'm multiplying it by
S over 1.
right. Now, if I divide in by S and I multiply by S, it's gonna cancel off. Aaron,
Yes,
I
sir.
need to clear up that confusion. Like, can you see? Like, okay, if it was 1 over S, yeah, it'd have been in the denominator. But if it's just S, S is in the numerator. That's just S over 1.
Yes, I get it.
So what I'm trying to say is the units for area is going to be meters. Do not put meters squared. Yes, I know you're finding for area. You are finding for area, but again, area is a product of two dimensions. The dimensions we are dealing with is meters per second and seconds. The seconds will cancel off, and that will leave us with meters. So generally speaking, anytime you're doing a kinematics question and they're asking for distance traveled, 90% of the time, just per meters. If you don't understand what I just show you, per meters. But the reason why is meters is because one dimension is meters per second and the other dimension is seconds, which is S over 1. The S is cancelled off to leave you with M. Yeah. You'll understand how I got the 1150 meters?
Yes, I get it.
So
Yes, sir.
the distance traveled, the total distance traveled is 1,150. And what was the total time taken?
300 seconds, sir.
Exactly. What would that be equal to?
I got the 3.833, sir.
How about the rest of you guys? So I got to write 3.83. Let me just verify that.
Yes, sir. Now I hear too.
So 3.83, right?
Yes, sir.
Yeah.
And when I did it, I got 3.83 as well. Nice. And the answer Guys, you are finding for speed, right? So what will the units for speed be?
Meters per second, sir.
Right, meters per second. And if you don't know, guys, if you don't know the units there, speed, meters per second. Right. So are we okay with a speed time graph?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, would. Let's look for a question in 2025 now. So we're gonna look for it in 5 years, right? See what they brought in 2025. They brought this question. Okay, yes, they brought it. Yay.
Is this June or January 2025?
It's January.
Oh,
January. And you know what exam are they writing? January. So maybe it might come.
that's what I was asking because I did January this year.
And you remember this.
Yeah,
So let me see how much it improved by, right? Let's see. First things first, guys. They give us a velocity time graph, which is the same thing as a
speed time graph, sir.
right. So what we did just now for the paper 3 question applies over here, right?
Yeah, sir.
Well, I'll understand this thing. If it's a velocity time graph, this region 1 over here, that would be acceleration, deceleration, or constant velocity,
Acceleration, sir.
right? This region over here would be
Constant.
Constant.
constant velocity, right? What about this region?
Acceleration.
This region?
Constant.
This region?
Deceleration.
Nice. Nice. Okay, and remind me, guys, if they ask me for average speed, how would I figure out the average speed?
That's the total distance traveled over the total time that was taken.
Right. Now, guys, this diagram a little wonky, right?
Yeah.
I do expect it to be that easy. It might have to split up the shape into compound shapes. So maybe you can split up this into a trapezium, see now,
Yeah.
right? Um, I'll be 5 sides, see now? 1, 2.
Yeah, sir. I see it.
So you would have to do for this one, maybe you might have to split this up. Well, you would have a trapezium here, and you have a trapezium here. It might be a little tedious, but it wouldn't be that hard, right? I don't suspect it being that hard. So you know what? I'll give a extra question. After we finish the question, I'm gonna make all find the average speed. So we can do that. Right. So word. The velocity time graph describes the journey of a car over a period of 70 seconds. So 70 seconds, right? The journey is represented in 5 stages, labeled 1 to 5. So somebody volunteer for this question. This is real easy, Max. Part 1.
During complete the following statement during the I'm not good with Roman numerals.
Oh, that's 4.
During the fourth stage, the car is traveling at
So the fourth stage. Fourth stage.
45 meters per second, sir.
Yeah, I don't understand why he said 45 meters per second.
Yes, sir.
Yes, sir.
Is it accelerating?
No.
No. No. So I already know the other answer, right? So 45 meters per second with an acceleration of mind me, guys. Is the car accelerating in this region?
No. So it will be
No,
zero.
zero, sir.
Yeah, that's all. It's in the name, right? Zero acceleration. Zero. Right. Part 2. Aaron, you gotta read from her.
Determine the maximum acceleration of the car during the 70 seconds.
Right. Now, acceleration is given by a positive gradient, yeah?
Yeah.
Now the maximum one will be the steepest one with the steepest gradient. So let's identify the periods in which the car was accelerating. Guys, what
Um, There's
period?
the first period and the third period, sir.
Which one has a steeper gradient? Just by looking at it.
Period 3.
Exactly. When I say steeper, right? Imagine you're driving a car and you have to go up like a hill. Which one looking?
Yeah. Period 3, sir.
Right. So period 3 would tell us the maximum acceleration. So, guys, for a velocity time graph or a speed time graph, how do I figure out the acceleration? By finding what?
The change in speed over time.
Right. And the mathematical way to do it is to find the what?
Gradient, sir.
Exactly. Find the gradient. Find the gradient, right? Now, I have a feeling that some students, when they open these notes and they see this distance time graph, they'll be like, but shucks, man, so didn't give us the displacement time graph. So you know what? Let me just paint it over here too. Because I feel like some people come at me. They might know that this at distance is the same thing as displacement. Right? Same thing. Let me just fix this. In case like I think didn't give all the information. And speed time graph is the same thing as what? Same thing as
Velocity time graph, sir.
yeah. Yeah, and remind me guys, if you want to find acceleration for a speed time graph, you find
The
Gradient.
change in speed over the time taken.
right, which is the gradient, right?
Yeah.
Gradient. Right. So I would need 2 points to find the gradient. So are you all seeing any nice 2 points along this region over here?
0.
45 comma 35 comma 45, sir.
Somebody said 0. No. Anything with 0, nah, you're off. You're a little off. You had to take points along this line. Must take points along that line. So I'm seeing up
Um
there.
what about the 20 at the end and 25, sir? Could that work?
I'll check that just now. Right?
Right at the beginning of the acceleration for period 3 at that point.
Yeah, this point could work. I want somebody other than Aaron to read this point off for me. So I will tell me the X value first.
25.
If that will be 25. And what is the Y value?
20.
All right, so that's going to be 25, comma 20. Which one do you want to call the first point and which one do you want to call the second point? Again, it doesn't matter. Which one do you want to call the first point?
25 and 20, sir.
Sure. If I call that the first point, right? Now we'll label this what? If I call this the first point,
That will
X.
be X1 and Y1.
right? And this if I call this the second point, what would I call that?
X2 and
X2
X
and Y2.
and Y2.
Right, and we know that the gradient,
It's Y2 over
Y2 minus
Y2 minus
Y1
Y1
over
over
X2 minus
X2
X1.
minus X1.
I like any energy today. I'm not hearing much people talking, but the people that are talking, well, it sound like they have energy, so that's good. How fast I just said that? I mean, I have energy.
Yes,
So you
sir.
get a good night's sleep last night, sir.
I'm still tired. I'm still tired. So I'll be honest, I'm still tired. Yeah. I trouble in this one. I leeching off his energy. Yeah. Right. So Y2 is 45. Right? Y1.
Minus 20
Tell me.
over 35 minus 25.
It's 45 minus 20.
20, 25, sir.
And 35 minus 25 is
10
10. So my answer,
is
max.
2.5
And the units for acceleration will be 2.5 meters per second. What?
squared.
Right, meters per second squared. So that's my answer. 2.5 meters per second squared. All right. Do you all understand why I picked this over this?
Yes, sir, because there's
Yes, sir.
this
Because
gradient
you have to pick the
acceleration.
steepest gradient for the maximum acceleration.
Right. And let me just say I had some trust issues, right? You know what you could do? You could find this gradient as well. So I'm gonna pick 2 points, right? And I want to read off the points from her. If I pick that point, what would the points be there?
15
0,
and
comma
20.
0 and 20, sorry, 15, comma 20.
Okay, do you all agree with the 15, 20?
Yes, sir.
Yes, sir.
Right. Here, I'm gonna do this thing fast, right? So I'm gonna call this x1, y1, and I'm gonna call this x2, y2. So the acceleration for this one, right? That would just be y2 minus y1, which is 20 minus 0, right? All over x2 minus x1, which is 15 minus 0, which is 20 over 15.
I got 1.33 recurrence.
Okay, for which period is the acceleration larger?
Period 3, sir.
And you can see that because for period 3 is 2.5 meters per second squared. Okay, is there anybody that does not see why this one is larger than this one? If you can't see it, right, guys, which number is bigger, 2.5 or 1.33?
2.5.
Right, 2.5. And we didn't even have to figure, we didn't even have to find for that, right? I just do it just for safekeeping, right? But ideally, you're looking for the one with the steeper gradient, which was 3. So far, how are we feeling about kinematics?
I think
Feeling
it's
good.
easy, sir.
Feeling like one of the easier topics, sense?
Yeah.
Yeah.
Yeah. It's only looking intimidating, you know. And after this question, that is it for kinematics. Easy 6 marks. Easy 6 marks, right? Okay. Somebody read this one.
Calculate the distance traveled by the car during the first 25 seconds of its journey.
So first 25 seconds. Are we gonna find the total distance traveled?
No.
No,
No,
just for
the first 25
25
seconds.
exactly right. Can we identify that this is the first 25 seconds?
Yes,
Yes,
sir.
sir.
Right, what shape is that?
A trapezium.
And so you know how you bad this is go by now? Most of the time it's a trapezium, right? So how would I find the area for that trapezium?
And the
A
area
half
underneath.
A plus B H.
We say Aaron, let you talk for a bit. Aaron,
Oh,
you're
sorry, sir.
I'm happy that we eager to answer that. That's good. That's good. The some energy come back. Right? So yes. Thelma, how would I find the area of the trapezium? Okay, I'll let you speak now. Aaron not talking right now. Let's take
So,
quiet.
by half by A plus B by height, sir.
Right. So the area of a trapezium is equal to a half A plus B by height, right? How am I gonna find the dimensions of A and B?
So the
Remind me.
button on top and then button on the bottom, sir.
What's the dimension on the top? See if we can figure that out from me.
20, sir.
Yeah. And no, 25. Wait, how did you get 20? Let me show you how we doing this, right? So what is this length of, like, what is this length over here? What is our distance?
15,
And what is this?
25.
So what would the dimension be in the middle? How do I figure out that dimension? How do I
So
figure out?
I got the divisor.
No, you wouldn't divide. If you want to figure out the what this is between 15 and 25, you'd minus. You have to minus. But I want you to understand why we minusing them, because I feel like that confusing you. If this is 15 and this is 25, and you want to figure out the space in the middle, wouldn't you take away 15 from? You take away 15 from?
25.
Exactly. So what's 15 minus 25?
10.
Yeah, sure you understand that.
Yes, sir.
Just to make sure you understand it, what will be the distance between here and here?
10, sir.
What about the distance between here and here? So about this.
20.
20. Now, it not be 20. Don't give up, man. Make it do it.
15.
Yeah, that looking like 15 because this will be 45 and
Yeah.
60 minus 45.
Yeah, 15, sir.
Nice. Right, so the top dimension is 10, that's E. What's the bottom dimension?
So I got to do the same thing, sir.
Show me you can do the same thing. If you do the same thing, we okay. Let me know again.
Sir.
10, nah, that wouldn't be 10. So if I want to
What
figure out
happened?
the bottom dimension, I want to figure out this entire thing over here. I don't want to tell you the answer. I want you to figure it out. What does that look like?
That look like 25.
Yeah, it is 25.
Okay.
And if it did what it was just doing, if this is 25 and this is 0, what's 25 minus 0?
25.
Right. Right. Nice. And what I figure out the height.
So the height will be 20.
Yep. So my distance traveled would be a half. What is A? Remember, what was A?
10.
A was 10. Plus B was B.
25.
Right, multiply by.
20.
Plug that into your calculator, let me know what you get. Just by looking at that, I'm looking like 350.
Yes, I got 350.
Yeah, I'll just see how I was moving when I get some semblance of sleep.
Yes, I get the same thing. 350.
Yeah, boy. Nice. 350. 350. And be careful there. Do not put meters squared. What's the units? You find in distance. What's the units?
Just
Seconds.
put meters, sir.
So somebody said seconds. Do we measure distance in seconds? Like if I ask you how much
No,
distance,
sir. People meters.
right?
Miles per second.
No, somebody said miles per second. No. If we're talking about distance, we measure distance in meters, measure distance in kilometers, we measure distance in centimeters, right? Yeah, anything with meters on it. or inches. We measure distance in inches. We measure distance in feet. I don't know if you guys understand this.
Yes, sir.
So I get it.
Okay. So on to the side quest now. I'm so good, all you can handle the side quests. I don't know, maybe they might. And if they bring this question, I feel like it might be the only question they might bring. In the first part, it will be like find for the total distance traveled, and in the other part, it will be like find the average speed. So guys, here was the question. I'm gonna give all a question to figure out the average speed. Find the average speed. Now remind me, if I want to find the average speed, what's the formula for that again?
Total distance traveled over total time taken, sir.
You already know what the total time taken is.
Yes, sir.
Yeah, the total time taken is, we know 70, right? 70, yeah?
Yeah.
Right, so here we go to, right? For us to figure out the total distance traveled, I need to figure out the distance under the entire graph. You do this. First things first. Let me
We
split.
already figured out the distance for the first 25 seconds, sir.
I already figured that out, right? What was our distance?
350.
This is already 350 meters, right?
Yeah.
So now we need to figure out from 25 to 70. Now, guys, if you look at this shape, right? This isn't like any shape you know. You can't see that it's a trapezium. How much sides I have?
4.
4. No,
Is that 5, sir?
5. That's not trapezium, eh? And we don't really know how to deal with a five-sided shape. So what I would advise you to do is, I would advise you to break this thing up into several smaller shapes. So is it possible for me to figure this out? Like, is it possible for me to figure out what this area is?
Yes, sir.
What shape is this? What's the name of this shape?
A triangle, sir?
A triangle. Nah. When you think of a triangle, right? What sides do you think of?
3 sides, sir?
Sides.
How much sides does it have in that shape?
4.
Tell me, how much sides is in there?
4.
4.
Aaron, you see only 4, right?
Yeah.
Are you seeing two parallel sides?
Yes, sir.
Aaron, you see any two parallel sides?
Yeah, sir.
So I want you to realize that there's a trapezium. Can you see why it's a trapezium?
Yeah, I can see it.
Yeah, don't feel shame, You're learning. It's fine. You should, like, great men fail, but like it would be great if it just continue after failing, right? You don't want to give up. So guys, can we see that this is a trapezium?
Yes,
Yes.
sir.
I think you might see it better if I take it and rotate it. Then it would be like, oh, yeah. See it?
Yeah, I see it now, sir.
Right? And then the other region over here. Right. Tell me, what kind of shape is this?
Is that also a trapezium, sir?
I don't way to ask me, a way to tell me. A way to tell me. Confidence, right?
A trapezium, sir.
It's still something like you're asking me.
No, sir, I'll be in serious.
Yeah, they'd be like, that's a trapezium. Yeah, that's a trapezium, buddy. Tell me. I gotta go ultra instinct. You gotta be like full call. You gotta be like, that's a trapezium. Okay, it's a trapezium, right? But why is it a
Yeah.
trapezium? Why is it a trapezium?
Because it have 4 sides.
No, you, Darius. I know you know this. I know you know it, right?
Yeah.
Aaron, what constitutes that to be a trapezium?
It has four sides and two parallel lines.
Yeah, that's it. That's it. That's it. Right? Now, what shape is this?
A trapezium.
Because it have how much sides?
All sides?
And how much are these sides parallel?
2.
Exactly, trapezium. So, do we know how to find the area for trapezium, guys?
Yes, sir.
So here I want all you to do for me. I want you all to figure out the purple area and the red area. I give it only 5 minutes. Cool. After this, I want to do 2 more kinematics questions. Then we're going to take a 10 to 15 minutes break. We're going to come back. We're going to look at patterns. That's real easy. That's real easy.
Yes, sir.
And then we're going to look at area and volume. And then measurements. Keep measurements. Boring. I'm looking at you guys and seeing what you're writing in your book. Man, tell you what you You're writing me with a kind of.
So the screen cut off. Oh, and come back.
Guys, and if you get the question correct, you're not gonna hook you up with a Devon coconut cream. You don't know, right? You get the question correct. Yeah.
Drop your address in the description below and we'll show up right by your door.
Don't want to pop up in front of anybody house. Let me hear them answers rolling in.
I got 900. So
Which one?
the purple one.
Okay. Let me just. Did anybody get an answer for the red one?
I thought we were working out the purple one first, and then we'd move on to the red.
Oh, I was asking her to find everything one time.
Oh,
Should I be a little more clearer? Um, did anybody get the area for the red one? I suppose not. The purple one. Let me see. Well, this thing went fast on the 20. 45. Nah, I calculated that wrong. The purple one.
yes, sir.
Nah, it wouldn't be. You got 900.
Yes, sir.
No, no.
So I think mine runs too, sir, because I get 1125.
You got 1125 for which one? The red one or the purple one?
The purple one.
Funny enough, 1125 is the answer for the red one, eh? So I'm not sure where you do that, but that's the answer for the red one. So here what? Let we attack this thing, right? I've seen a lot of confusion. So I'm gonna put down a trapezium here, right? This dimension would be E, and this dimension would be,
B.
B,
and this dimension would be.
the height, sir.
Okay, what if I now draw it like this? What would this dimension be?
Is B, sir.
You can call it A or B, it's fine. Call it A. How much of you guys think that this will be the height? Raise your hand.
Nah.
No.
Okay. What would this dimension be?
B,
And what would this dimension be?
the height.
Okay, do you all understand this?
No, I get around.
Yes, sir. Yes, I see it. I get.
You know, do you, like, be honest with me? Do you understand this or not?
Yeah, I understand it. Yeah, now that you say it, sir, but while I was doing it, I didn't understand that I was doing it, not all.
All right, so I need to understand that A and B are the parallel sides, right? The parallel sides over here. And these are the parallel sides.
Yes, sir.
Yeah, you wouldn't call this H. So let me ask that question. Over here, right? Which sides are the parallel sides? 1, 2, 3, or 4? Which ones are the parallel sides?
1 and
1 and 3, sir.
1 and 3.
Right. So let's find the measurements for that, right? What would this measurement be?
I have it as 25, sir.
25. Nah, watch. You see, you know what I'm talking about? Watch that again, right? Here and watch. That's from 0 to,
0 to 20, sir.
right, so that's supposed to be 20.
Oh,
What would this dimension here be?
45, sir.
Yes, 45 is correct. Aaron, did you get that one correct? Or did you say it was 35?
I said it was 35, sir.
Let me explain why I was wrong, eh? That is 35. That is 35. Understand that. 35 is from 0 to 35. This is where you're finding for. Do you understand that?
Yes, sir.
We actually want to figure out. Wait, I'm gonna ask that question. This is a vertical or a horizontal length?
Ah,
That's vertical or horizontal?
horizontal
Nah.
or vertical? Vertical.
This is horizontal. And this is,
And that's vertical.
so will you take a horizontal reading for a vertical reading?
No, sir.
Nah, so you was finding the horizontal, but we wanna find the vertical length. Understand?
Yeah, I get to understand where I went wrong, sir.
100, like a sure.
Yeah, sir, I get.
I had no room for confusion in that head. No room at all. Kick that confusion out. Push that confusion out of the plane. That confusion had to die today.
Mm-hmm.
Push it off the building. We big shambles. It's a killing it. Down that. Right. Now, guys, now, do you
Yes, sir.
understand that this would be A and B?
Yes, sir.
So you tell me what would H be? You tell me what would H be?
Across, in between
In
in between A and B.
so you tell me what our length would be, and I'll tell you if you're correct. And I'll tell you if you're correct.
10.
That is correct. Excellent. So Aaron, do you understand that that is a horizontal read off? That's a horizontal reading.
Yes, sir.
So you'll be taking the reading between 25 and
35.
35.
so come. I want you all to calculate. Here what? Time to redeem all yourself, right? Redeem all yourself. Take another 5 minutes and cook. Figure out what the area for this is supposed to be, and figure out the area for the red one as well. You all can do it. Come on. I know you can do it. Do I have any do I have any answers for the purple area?
So for the purple one, I got 325, sir.
Or anybody else? Don't know. What did you get?
1125.
Nah. Something we can I'm real curious to see what you know. Because like I said, 1125 is the area for the red one, not the purple one.
Oh, I get 325 for that one, sir.
Oh, and 1125 for this one.
Yeah, and 1125 for the next one.
Oh well, yeah, you're good, you're good. You're good. Right, so I'm gonna answer the question, right? Right, so Aaron, for the purple trapezium, right?
Yeah,
A, A is what?
A is 45, sir.
Again, it don't matter which one they call A and B, right? Because addition is commutative. It don't matter if you say 20 plus 45 or if you say 40 plus 25. So it's gonna be a half. 20 plus 45 multiplied by what?
Multiplied by 10, sir.
And everybody getting 325, yes or no?
Yes, sir.
And that being meters, right?
Yeah.
Okay, what about the red one now? Tell me, what is the dimension for A? A is what?
So I get 15, sir.
Yeah, 15. Because I'll be 35 from 50.
35 to 50.
And what is the bottom dimension?
Or so I get 35, sir.
I got 35, right? Because guys, watch. What is the distance from 35 to 70? That would be 70 minus 35, right?
Yes.
I already have the height. The height is 45, yes?
Yeah.
Yeah.
So A is just going to be equal to a half 15 plus 35 multiply.
Yes, I got 1125, sir.
Awesome. 1125, right?
Yes, sir.
Well, I read the time. Well, you see that? That's crazy. 1125 meters. Damn. I don't need stuck. I need some more sleep. Yeah. So guys, we know what the red area is, right? And we know what the purple area is. So let me ask that question. What was the total distance traveled then? Could somebody tell me? Guys, how would I figure out the total distance traveled? Why so quiet, man? Why?
Yeah, add up everything.
Yes, that's it. You add up everything. What we adding up?
350, 325, and 1125.
And what would you get? So that'll be 670.
1800.
Yeah, 1,800. So that'll be 1,800 all over. What was the total time taken?
70.
Right. So 1,800 over 70 is,
I got 25.71, sir.
and the units would be, wait, it'll be meters per second, right? But let me just address
Yeah.
something. The total distance traveled was the 1,800, right?
Yeah.
Right. Put it over here. And that'll be meters, obviously. So to figure out the total distance traveled over the total time taken, you're gonna recall what that was. That was 1,800. Yeah. Right, so do we understand how I figured out the average speed?
Yes, sir.
I feel like if they bring a question like this, that'll be all they're bringing. They might just be like, find the average speed. And the first part, it'll be like find the total distance. That might be like a 3-4 mark question. And then the other question will be a 2-mark question. That'll make up all the marks. So guys, are we gonna get fooled when they change the orientation of the trapezium?
No, sir.
No,
No.
sir.
Again,
Sir.
yeah, Darius?
Said no, sir.
All right. I mean, if you wanted, you could also convert everything to like a rectangle and a triangle. Right? So you have a rectangle here, a rectangle over here, triangle here, triangle here, triangle here. But I feel like that's so much work. Right? So remember, guys, A and B are the lengths of the what sides? The what sides?
Yeah, they are the lengths of the parallel sides, sir.
Right, parallel sides. Great. All right, let's move on. I don't think they brought this in June 2025, did they? Let's see what they did. They did. And they brought us speed time graph again. Say no more. We know how that's go, right? Guys, and we know how that's go. I know.
Yes, sir.
Yeah, we know how that's go by now. Who wanna help me with this question? Like, I want to speed through this question. Who wanna help me with it? Can I hear anybody? Darius, you wanna speed through this fast?
Yes, sir.
All right, so the following diagram is the velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes, travels at a constant maximum speed, and then slows to a stop. All right. So you can see that over here, right? Darius, from looking at the diagram, we can see that this is acceleration. Yeah, that's acceleration.
Yes, sir.
This region over here is what?
Be constant.
Right, no acceleration, and this region is
Deceleration.
great. It's kind of bad copy, but oh well. So this is acceleration, no acceleration, deceleration. Cool. What do you want me to figure out in the first part?
Determine the initial acceleration of the car.
Fast speed time graph. How do I find the acceleration?
The distance divided by time taken.
No, if you say distance divided by time taken, you would get speed. Distance over time is speed. Darius, anytime you have a speed time graph, you find the gradients. Or it'll be change in speed over the time taken. Right? So again, anytime you have a speed time graph, speed time, velocity time, same thing. You find the gradients. So Darius, you're going to take 2 points from the region for which the car was accelerated. So you need to take 2 points along this line. What 2 points do you want to take?
Um,
I'm Darius.
wait, how much is one block?
1 block. 1 block is 60. So one small one will be 60 divided by 5. Each small block is 12. You understand? So like
Yes, sir.
12, 24, 36, 48, 60. So what's the easiest point I could take here along this line? What's the easiest point I could take?
You could take the t and the
Right. So I see what you're saying, but the easiest point to take would be 0, 0. That's the easiest point, one of the easiest point I could take. And then the next point you're talking about, you are talking about this point.
Yes, sir.
Now let me show you a hack, right? Check this. Right. Watch this hack, right? Can you see that this is in the middle of 60 and 180?
Yes, sir.
All I would tell you to do is just add up 60 and 180 and divide it by 2. You get 120. What's 120?
Yes, sir.
You understand that?
Yes, sir.
So here I'm saying again, guys, if it's in the middle, just add up the two values and divide it by 2 to find what's in the middle. Because when you divide by 2, you find what's in the middle. So you'll get 120. So my other point is 120, what?
Time 120 or 30.
Right. So I have the points 0, 0, and 120, comma.
30.
So I could call this x1, y1, call this x2, y2. Remember the gradient is y2 minus
y1 over x2 minus x1.
So your acceleration is going to be equal to y2. Y2 is 30 minus what?
Minus 0.
All over.
120 minus 0.
And what do you get?
A quarter.
Right, which is 0.25. And what's the units for acceleration?
Meters per second squared.
Right. Is there anybody that did not understand how I got the acceleration like at all?
No,
Nah,
sir.
sir.
Okay.
No, sir, I get it.
All right. And look at what they go ask. We know how to handle this. Darius, what do you want me to do?
Calculate the distance between the two towns.
Right. So Darius, if you want to find area, or I was saying, if you want to find distance, right, what do? You
You have
find
to find the area of the entire shape below.
right. So you find the area on the graph. Some of you might be confused, like, what do they mean by between two towns? Well, at the start of the question, they said it shows a car's journey from town R to town Q, right? Do we understand that?
Yes, sir.
So,
Yes,
like,
sir.
you leave here, right? You move at a constant speed, you drive at a constant speed, and then you start to slow down, and then you reach town R. That makes sense?
Yes, sir.
Well, I say town R, town Q. So this is R, and this is Q. Let me just run through this scenario again, right? So guys, you'd leave R because you want to go from town R to town Q. You would have left R and you would have moved at you'd accelerate, you start to accelerate. Then you would reach a constant speed and you would stay at that speed. Then you would start to slow down because you're reaching your destination and bam, you reach Q. Aaron, I needed to be honest with me, does that make sense?
You can explain again, sir, just so I could be extra clear.
All right, so they're saying that the diagram below shows a car's journey from town R to town Q, yeah? Town R to town
Yeah,
Q. You're starting from rest, right? If you want
yeah.
from town R to town Q, where would you be starting from?
Rest, so 0.
Right, but you'd be starting at rest from town R.
Yeah,
So you're starting from town R. Imagine you get into the car, and you would have to accelerate to get the car moving.
yeah, sir.
So you're accelerating on a constant rate, and you find a comfortable speed, and you say you reach the highway, you reach
At 30.
and you keep at that speed, yeah?
Yeah.
And you start to slow down because the destination getting closer. So like you start to decelerate,
Mm-hmm.
and over here eventually stop. You would stop when you reach.
0.
There's no more I want to hear.
Q.
You're going from town R2?
To town Q.
Right. So you would stop when you reach your
Town Q?
exactly. You would stop when you reach your destination. So do you understand that from here
Yes, sir.
and from here, this is Q. That's the final destination.
Yes, sir. I see it. I get it.
So what kind of shape do we have here, guys?
A trapezium.
So if I want to find the distance traveled, I would need to figure out the
The area
The graph below.
under the graph.
so guys, could somebody tell me the dimension for A? Before we do that, what is this dimension over here? What would this be? You remember the trick I showed you to figure out what's in the middle?
Um, Here, add the 2 and divide by 2.
You
Right.
add and then minus and then divide by 2, sir.
What do you get?
650.
650.
Wait, nah, I did that wrong.
Nah, 600. Because that'll be 60 plus 40 is 60. So be 100. 100 plus 500 is
Yeah,
600.
I got 600, sir.
Yeah. Right. So guys, can we see that that this is 120 and this is 600?
Yes, sir.
Yeah,
So Aaron, what would be the distance in between 120 and 600?
480, sir.
Right, 480. Right? Then I'll help me figure out the bottom dimension. That's going from 0 to what? Then this one will be a little hard, right? Because you're not seeing anything over here. And
840, sir.
how much?
840.
Okay, well, big up you. I thought you'd have some trouble with it, but yeah, you figure it out. Right? So you add 60 to 80 and
Yeah, sir.
Yes, sir.
yeah. So it's gonna be 840. Are you okay with that, right?
Yeah, sir.
Yes, sir.
All right. So, and what's the height? Somebody tell me what's the height?
Titty.
Right. So what would the area be? Right, what's the formula for the area for this? Area is
Half A plus B by height.
Half A plus B times height.
right. So the distance traveled. The distance traveled would be what? That would be a half.
So I got 100. I got what I got 198 19,800.
Let me just verify that.
Yes, sir, I got that too.
How much?
19,800.
So now I'm gonna figure in that.
Yes, sir.
Okay, good. Right. So guys, I'm gonna do one more kinematics question. Right, one more. Let me see if it come in January 2023. We did this already. So paper 3. Um, okay, it did not come in January 2024. But to end this thing off, I would like to do a instead of you doing a speed or a velocity time, let's look at a distance time. Right. So guys, is this like the others we did or like slightly different? So guys.
Hmm.
It's kind
So
of like the others, but just a little slightly different.
Right, because what do we have on the y-axis this time?
Distance.
distance.
We have distance, right? So
Mm-hmm.
the first part, what was the average speed during the first during the first 2 hours? Now, guys, when you look at the dimensions, you see that this is in kilometers, right?
Mm-hmm.
You see that this is in hours. So don't get
Yeah.
so first 2 hours, right? The first 2 hours will be over here. See now?
Yes, sir. I see it.
Now, guys, for a distance time graph, what does the gradient give you?
The
The
distance and the distance and the time, sir.
No, check back the screenshots. What does the gradient for a distance time graph give you?
velocity,
Right. The velocity or the speed, right?
the speed.
Right. So gradient. Okay, Aaron, remember that, right? And if you are confused, right? Isn't the formula for gradient y2 minus y1 over x2 minus x1?
Yeah.
There's only y-axis for this. In this graph, what's only y-axis?
Will it be 212, sir? The first point
Now, asking you, what do we have on the y-axis here? What's the dimension?
of the distance.
We have distance on the y-axis, and what do we have on the x-axis?
The hours, sir, the time.
Right. So you effectively defining distance over time, which is what? What is distance over time give you?
Speed, sir. I'll
Exactly.
give you the speed.
Right. So if you have a distance time graph, gradient gives you speed or velocity. So we need to pick 2 points along this line over here. And by the way, guys, just remember through the interpretation, from 0 to 2 hours, is the person moving away or getting closer to their starting point?
They're moving away
Now
from
we
their starting point,
They're
sir.
moving away.
Right. Because as the time increases, what happens to the distance the person travels?
It goes up.
Right. So the person is moving away from start. Now, for this region over here to over here, is the person moving?
No, sir.
Oh, the constant.
Right. Now, they're not moving, eh? They're not moving. Like, okay, with a speed time graph, the person's still moving, right? It's just moving at that constant speed. But over here,
Mhm.
guys, are
They
they,
just they they just stop, sir.
they just stop, right? Not moving. Not moving.
So you can say that they stationary, sir.
Exactly. Stationary. That's the correct stationary. Like, there's always mix up the one E and A.
I think that's the right one, sir. I think the E is like school supplies.
A. Okay, yeah, fine. Be good, be good. Good. Yeah, teach English now. No, 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 I won't touch English. Yo, right? And guys, if this is moving away from the start, right? As you can see here, I'm decreasing my distance. I'm going back to the
Starting point.
right. Moving back, moving towards the starting point. In case I ask you to explain the interpretation, moving towards Cool. So 2 points. I'm going to pick this point over here. That's the easiest point, 0, comma 0, right?
Mm-hmm.
And the other easiest point is this point over here.
212, sir.
Yes. 0, 0, and 212. 0, comma 0, right, and 2, comma 12.
Will
Let's just,
be 0, the 0, 0 will be x1, y1, and the 212 will be x2, y2.
right, so the average speed that would just be equal to y2 minus y1. That'll be 12 minus 0 all over.
All over 2 minus 0, sir.
Minus 3.
What's 12 over 2?
6, sir.
And guys, be careful, eh? The y-axis, what is the units?
Kilometers.
Right, so on the y-axis is kilometers. And on the x-axis, what are we measuring?
The hours.
Right, so my units are going to be kilometers over hour, which is km. Is anybody confused by that?
No, sir, I get it.
Sure.
All right. Are you sure you understand this? Like, tell me.
Yes,
Yes,
sir.
No, sir, I get it.
Okay, part 2 now. Part 2. What is part 2 asking?
What did the athlete do between the 2 and 3 hours after the start of the journey?
So 2 and 3 hours. What do you think he did?
He took a break, sir. He didn't move.
Yeah, he took a rest. And they're seeing that between 2 and 3 hours, like he not moving, right?
Yeah, sir.
Take a but he was sleeping. Man fall asleep. Man knock out. Don't put any exam. Eh? He said he man took a rest. He wasn't moving. So part 2. The one said the man dead. Yeah, and like what happened, right? Like they pick him up from his side of the road and carry him back home.
Yeah. And the ambulance. That's the ambulance.
So once that's the ambulance coming, yes. So the athlete,
Videos.
Was in a state of inertia.
yeah. For those who don't know what inertia is our body's ability to resist a change in motion. That's what inertia is. The athlete took a rest. In other words, he was not moving. In other words, he might be dead. Somebody go check on him.
Make sure he is.
Yeah. Part 3 now. Okay.
What was the average speed of the return journey?
Right, guys, what's the return journey?
The journey back towards the starting point.
So, Aaron, do you think our interpretation was right?
Yeah,
Because here what it's asking us, right? On the return journey. If it's a return journey and you're returning back to your starting position,
yeah, sir.
yeah. So we need to figure out, we need to take 2 points here.
The easiest point would be
What's in between 3 and 4?
3.5, sir.
Yeah, but there's an easier point. I see an easier one. Check it out.
I see it. Yeah, 4.8, sir.
And this one is
Um, 0, 5, sir.
5,
5,
comma, 0.
0.
Why am I saying 5, comma 0? I'm saying that because I moved 5 spaces along the x-axis and 0 spaces along the y-axis because I stayed there. Make sense?
Yes, sir.
So 4, 8, and 5, 0. You're going to get a negative gradient. I'll show you what to do with that shortly. Which one do you want to call X1, Y1, and X2, Y2?
Or it as x1 and y1
Right? And 5, 0 was?
as x2 and y2.
Right? So we know M is equal to, what's M?
y2 minus y1 over x2 minus x1.
Great. So I'm going to put velocity, and you'll see why I'm putting velocity, because it can't have negative speed. Velocity is the scale, is the vector quantity for speed. So velocity is going to be equal to y2 is 0, minus y1 is 8, x2 is 5, x1 is 4. You're going to end up with minus 8,
Yeah,
all over 5 minus 4 is 1. Now again, guys, you can't have a negative speed there, so that's why I'm changing speed to velocity. So, okay, speed and velocity is hand in hand, right? But the thing is, you can't have negative speed, right? Speed does not have a direction. Velocity, on the other hand, velocity is like speed, but it could be positive or negative. So if I see a negative velocity, it just means I'm moving in a different direction. We did
okay,
vectors today, right, guys?
yeah,
But if you have let's just say I had 5 meters per second. If I told you 5 meters per second was you moving in that direction, then negative 5 meters per second would mean that you're moving in the opposite direction, right?
yeah, sir.
So your velocity is going to be negative 8 meters per second. Now here what I'm going to write, they are asking me what is the average speed on a return journey. I will say the average speed, can speed be negative?
No, sir.
No. The average speed on the return journey is what?
Is 8, just positive 8.
Now let me explain why, right? Let me explain why. Understand this. The velocity will tell us the direction, right? It will
Yeah,
tell us the direction. Now negative 8, we know that negative 8 means that you're going back to the start, right?
yeah,
Now if I already have in the like, okay, if you read this sentence, right? Aren't I explicitly saying that we're returning back? Because I said return journey.
yeah, sir.
If I say I'm going, if I say it's a return journey, then I don't need to say it's negative,
Oh,
because the negative by itself would imply that you're going back to the start. But if I say return journey, it is implied that I'm going in the opposite direction. So you're just going to put 8 meters per second. Let me know if you're confused, but I understand.
no, sir, I get it. I understand.
All right, so guys, if they ask you for the average speed of the return journey, whatever the case may be, right? The gradient is going to be negative, right? The gradient is going to be negative, right? So so how are you going to write your answer, right? For your final answer, you're going to say the positive. So you'll say the average speed was equal to the positive of whatever the gradient was. Because when you find the gradient, you're actually finding for the velocity, right? So the speed would just be the positive component. So if you get negative 8 meters per second, right, you just write 8 meters per second, because I'm saying that it's a return journey, meaning I'm returning back. All right. So that's it for kinematics. How are you all feeling about kinematics?
Pretty easy, sir.
Normal.
I would say it is easy, right? I would say it is easy. So take a break. Come back at I think. Come back at I'll just come back at 3 o'clock. Come back at 3 o'clock and we're going to do pattern like and recognition. That's what we're gonna do, recognition and patterns. So like when I say that, I'm talking about these types of questions. And they come every single year. I see what I'm talking about.
Yes, sir.
Yes, sir.
We could do like 4 years of past papers for this. This is not hard. I'll show you the trick. And after we're gonna move on to area and volume, which is fun. So yeah, guys, see you later at 3 o'clock. All right, guys, ready to start back. Let me know. Are you all back?
Yes,
I
sir.
just drinking something, sir. I'm still about here, sir.
You sound like you're stuffing a double song, neighbor.
So I just finished eat a double, so I wanted to eat lunch.
I's a psychic. I's a psychic. Wait, boy. How I know that? I tell you, I'm looking at all you know. I'm looking at all. I'm gonna be seeing me writing in that exam. Yeah, I'm gonna be on my shoulder like
So
that.
if I write anything wrong, you would just let me know and I'll change the answer.
See no more.
Anytime I make a wrong move in the exam, I just go in and think about what I'm gonna say, then I'm legal, and like I swear I'm gonna pass the exam.
So on, roll up for them. Say. He getting himself prepared. And illegal. Yeah. Right. So let me jump straight into it. Making mistakes. It's not legal. Right. Mistakes not legal, right? So guys, any volunteers? Any volunteers?
Yeah, sir.
All right, there we go, right? So if this is diagram one, this is diagram two, and this is diagram three, what do you think gonna happen with diagram four?
It will add on one more, sir.
Yeah. Is anybody confused by this?
No, sir.
No? Okay, cool. So let me show you a hack, right? For all these questions, right? Um, there's a common pattern. So let me show you what I'm talking about, right? Give me a second. Let me show you what I'm talking about. Let me erase everything here. Right. First things first, let's look for a general pattern. 5, 8, 11. What do you think the next one will be? And come back, we add on what to each one.
3, sir. So it'll be
So,
14.
right. Now, let me show you the trend I'm talking about, right? So, the question I'm going to ask you, right, is 2 by what plus what would give you 8? That's what I'm going to ask you, right? And the other question I'm going to ask you, right, let's just look at 3. 3 by what plus what will give you
11?
11. So we need to figure this out. Let me hear some suggestions. 3 by,
3 and 2, sir.
okay. If you tell me 2 here, right, what would I have to add on to that to get 11? I'd have to add on 5 because 3 by 2 is 6, 6 plus 5 is 11, right?
Yeah.
If I do that over here, will I get back 8?
No, sir.
No, so that's not correct.
So I said 3 and 2, as in 2 by 3 plus 2.
Oh, like that. Like that.
Yeah.
Let's see if this is going to work, right? So if we pick 3 and 2, will it work over here? What's 3 by 3, guys?
9,
That's 9 plus 2.
11.
Let's check to see if it would work with 4. So 4 by what? 4 by what plus what will give you 14? Let's see if it will work. 4 by 3 plus 2. Guys, what's 4 by 3?
12.
12 plus 2 is?
14.
Right. Word. And this number over here is just the what number?
The diagram number, sir.
Right. So the general pattern is n multiplied by 3 plus 2. So it's just 3n plus 2. So that's what I'm going to put over here. 3n plus 2. Did you understand that?
Yes,
Yes,
sir.
sir.
Well, let me apply that same trend over here, right? For the number of lines. Let's see if it will work. So my question is, so let me start off with say 1, right? 1 multiplied by what plus what will give you what? We're dealing with number of lines now. Equals to,
7 plus 1.
wait, I'll put that equal to 8, right? And
Yeah.
you said 7 and 1. Let's see if that will work for 2, right? So 2 by what plus what would give you 15? Will 7 and 1 work as well?
Yeah.
Yeah.
Yeah, it would work. 2 by 7 is,
14.
14.
and 14 plus 1 is
15.
15.
good, right? And let's see if it's going to work with 3. So 3 by what plus what is equal to 22. 3 by 7 is 21. 21 plus 1 is 22. So guys, again, 1, 2, and 3 is just the diagram number represented by n. So the general formula here is what?
The number of lines, sir.
Right? And you're probably wondering, why am I saying n instead of l? When you write in the answer, you have to write your answer in terms of n. Right? So guys, 1, 2, and 3, right, is just n, diagram number n, right? And I'm multiplying that by what? In all the examples, I'm multiplying that by,
7 plus 1, sir.
which would be equal to 7n plus 1. Yes or no? Tell me if you understand that.
That's how I
Yes,
get it.
sir.
So 7n plus 1. And this will be the case for every single question. So again, you're going to ask yourself, you're going to pick one of the diagram numbers. So let me just say pick 2, right? 2 by what plus what would say give you 8. Then do with another one. So 3 by what plus what will give you 11. And you just find for one that would satisfy all the conditions. And you get your answer. Do you all understand the trick?
Yes, sir.
Yes, sir.
If you do understand the trick, you can tell me now and I'll re-explain it. The trick not that hard to understand. Okay, right. Let's fill out the rest of the table. It looked like we added on what consecutively.
7.
Right. So you got add 7 to 22 and that'll be 29, yeah? Let me know if you understand that.
Yes, sir.
Sir.
And if you don't want to do that, guys, and we just came up with the formula for this column.
Yeah.
If I put 4 into this until we get 29,
Yeah.
yeah, I would, right? 4 by 7 is 28. 28 plus 1 is 29. Nice. Now I need to figure out what's going here and what's going here. The first thing I should probably do is figure out what number that is. So guys, if I know that this is 59 and the formula for here is 3n plus 2, is it possible for me to figure out n?
Yes,
Yeah,
sir.
you need
No,
to, you
minus
need to
2
find
and
answer.
then divided by 3.
Exactly. So I'll put 3n plus 2. I'll put 3n plus 2 is equal to 59, right? I'll move across the 2, right? So that'll be 3n is equal to 59 minus 2, right? And then that'll be equal to 57. Then, like I said, I would divide by 3 to find for n.
19, sir.
Is everybody okay with me getting 19?
Yes, sir.
Right? And if the number is 19, how am I going to figure out for this?
19 by 7 plus 1.
Yep. So 7 by 19 plus 1. What do we get?
I got 134, sir.
All right, big up Froggy, by the way. Big up Froggy. One what?
134.
134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134. 134.
134, sir.
1 to the 4. All right. Could anybody else verify that? 1 to the 4?
Yes, sir, I get that.
Okay, would. Would. Right? Easy or hard? That's 6 marks, guys. Wow. So say 6. That's 8 marks so far. Wow. Wow. That's like easy 8 marks. How are you feeling about that?
Good. These are paper too?
Yeah, this is paper 2. This is come every single year.
I always used to find pattern real easy, in CSEC.
That's good. That's good.
The only really real problem was trying to draw the diagrams. So
Oh,
I know what I needed to draw, but I can't draw good at all.
I see. Right, now help me with this question. One of the diagrams in the sequence has 148 lines. So 148 lines, right? So I'm going to underline that one time. The formula for lines is 7n plus 1. Maybe we might have to use that. And they want us to calculate the number of dots. Calculate the number of dots. What's the formula for number of dots?
3n plus 2.
Okay, guys, so if I want to work this question out, let me hear some suggestions. How would I do?
So you'll have to say you could write it as 7n plus 1 is equal to 148, and then find for n, so
Right, I like where you're going with this. Right, and once I have for n, what I could do?
I got n is equal to 21, so
And you get 7n is equal to 147. Then to find for 1n, you would divide both sides by 7.
by
7,
7.
7 could go into 14 two times, and 7 could go into 7 one time, so 21. Uh-huh. So, okay, guys, if we have n is equal to 21, right? How am I going to find the number of dots now?
Then it'll be 21 by 3 plus 2, so to
Right.
find number of lines.
Now, dots, you mean? You mean number of dots.
Yeah, sorry, number of dots.
So that'll be 3 by 21 plus 2, which should be 65.
Yeah, sir.
Is there anybody that did not understand this at all?
No, sir.
Okay, we feeling, guys, this is 10 marks, This is 10 marks, right? Or I think I'll get 10 marks.
Yeah.
Yes, sir.
Yeah.
All right, I think so. Me, And all you're gonna see is the same pattern not gonna work is the same pattern, right? Okay. So, do I have any volunteers? Someone British?
Yeah, Joe, that next one we're gonna be upside down.
Yeah. So then now that's you, and
No.
Adika, that's you.
Yeah.
Oh God. Please, boy. Some of you okay with this?
Yeah.
Are we confused by this? Or like we fine?
Now I'm fine.
Are we fine, guys? We're getting that 2 marks?
Yes, sir.
Okay, cool. And I promise you, it's the exact same trend, right? So let me show you what we're gonna do. So, watch, right? It's the exact same trend. 1 by what plus what would give you what? Let me look at sticks first. So 1 by what plus what is equal to? Guys,
Sir.
4 plus 1.
right? So he said 4 plus 1, right, let's see if that will work for the other one. So for the other one, it's going to be 2 by some number plus some number, and that will give us 9. So you said 4 and 1?
Yeah.
Let's see. 1 by 4 is 4. 4 plus 1 is 5. Checks out. 2 by 4 is 8. 8 plus 1 is 9. It checks out. Let's check it one more time. So 3 by some number plus some number is equal to 13. So 3 by 4 is 12. Right? 12 plus 1 is 13. Yes. So tell me, Adika, what's the general formula then? If we know that 1, 2, and 3 is just n.
N multiplied by 4 plus 1.
N multiplied by 4 plus 1. And I can write that as 4n plus 1, yeah?
Yeah.
Easy or hard?
Easy.
Easy, right? We get in this 10 marks for sure, for sure. For sure, for sure. Right? Adika, since we on this topic, let me figure out the formula for the number dots too, right? Right. So you ready to mash this up?
Yeah.
All right. So 1 by what number plus what number is 5, don't say 4 and 1, eh? It's a different combination. 2 by what number plus what number is 8. And 3 by what number plus what number is 11. Do you all have any suggestions?
Yeah, 1 by 2 plus 3.
Let's see. 1 by 2 is 2. 2 plus 3 is 5. That does check out. 2 by 2 is 4, but 4 plus 3 is not 7. I mean, it's not 8. Nah, that doesn't, that's not working out for the rest of them. You see what I'm talking about? Watch, because 2 by 2 is 4. 4 plus 3 is 7. That's not 8. So think about another possibility. Okay, I see it. I see it. I'll wait to know. I want to see what I can come up with it. Maybe we could look at 11. 3 by what plus what is 11? I see. I see it too. What about you guys? Guys, all I can do is, Adika, don't stick, man. You can do this. Adika, you
See,
have it
I'm
too.
thinking.
3 by what plus what is 11? Okay, let me run 3
3
possibilities.
by 3 plus 2.
Yes, look, you get it. You get it. 1 by 3 is 3, 3 plus 2 is 5. Nice. 2 by 3 is 6, 6 plus 2 is 8. Nice. 3 by 3 is 9, 9 plus 2 is 11. Nice. So my general formula is what?
3n plus 2.
That's it. 3n plus 2. Easy or hard?
Easy.
Yes, man. Easy, right? Cool. How would I figure out what going here and here? Come on, Dita.
20 by 4 plus 1.
So 4 by 20 plus 1, that'll be 81, yeah?
Yeah.
And for over here, the 3 by 20 plus 2. 3 by 20 is
60.
60 plus 2 is?
62.
Right. Okay, if we know that what is 169 here and the formula is 4n plus 1, what is my next move, Adika?
169 minus 1 divided by 4. And
Yes.
you'll get 42.
Right, so 4n plus 1 is equal to 169. You take away 1, right? So 169 minus 1. So 4n will be equal to 168. Then you divide both sides by 4. 4 into 16 is 4, 4 into 8 is 2, so 42. And you get 42?
Yeah,
Okay, so if n is 42, right? What would this be?
it will be 42 multiplied by 3 plus 2, and
Right?
it will be 128.
128? All right, so
Yeah,
far, Adika, you feel like you'd get the 8 marks?
yeah.
Okay, nice. On to this question now. So Adika, get this a read for me.
Write an equation in S, D, and N to show the relationship between the number of sticks S and the number of dots for figure N.
Right. So the number of sticks is given by 4n plus 1, right?
Yeah,
And the number of dots is given by
3n plus 2.
all right. So they want me to write an equation in S, D, and N to show the relationship between the number of sticks S, right? The number of sticks and the number of dots for figure N. Okay. So let me think. So Adika, they want me to figure out a relationship linking S to D, right? S to D. S to D. So like, algebraically, I thinking we could make an equation. Let me show you what I'm thinking of, right? So if I make n the subject here, right, that would be s minus 1 all over 4, and that would be equal to n. And then I could plug that into this equation, and that would be d is equal to 3 s minus 1 over 4 plus 2. And that would give us an equation with s, d, and n, right? For the relationship between the number of sticks and the number of dots. But I still feel a little iffy about that. If I expand that out, I would get 3s minus 3 all over 4 plus 2. But I still feel a little iffy about that. I feel like there's a more elegant solution. So Adika, let me just run back. Let me look for a direct relationship, right? A direct relationship. When you're looking at this, right, Adika, both of them start off at the same number, yeah?
Yeah,
And then the difference, what happens to the difference?
the minus 1, then the minus 2.
Right? And then the other one, you think the minus?
No, it will just stay.
Say that again?
It will minus 2 again and just keep going down.
Right. So the difference here is 0. So difference here is 0. Difference here is 1. Difference here is 2. The next one will be a difference of 3. So what I'm noticing is that, so I'm going to say we started off at 0. So that would have to be n minus 1, right? So difference of 0. And then when n is equal to 2, that'll be a difference of 1, right? And so that'll be s plus n minus 1 is equal to d. That's what I'm thinking. It makes sense, right? Adika, let's test and see if it makes sense, right? Let's see. So Adika, when n is equal to 1, when n is equal to 1, right? What is 1 minus 1?
0.
So it will be s plus 0 is equal to d. So when n is equal to 1, can you see that s is equal to d?
Yeah,
Okay. When n is 2, right? Can we see that the number of sticks is 1 more than the number of dots?
yeah,
Okay. when the number is 3, you will get S plus 2 is equal to D, right? When n is 3, can you see that the number of sticks is 2 more than the number of dots?
Yeah,
So did we come up with a relationship that linking it together?
yeah.
Yeah, so this is the answer. I'm sure this could work somehow because you're making a relationship linking S and D, but I don't think this is what it was looking for, right? I think this is the answer. This makes sense, right? Right. Who would have not figured out this one? I feel like it's a tricky-ish kind of one, right? I don't know how to like think about it like a second time. But who would have gotten this answer? Do you think you'd have gotten this answer?
I'll probably leave it out.
I don't think so, sir. Sometimes I mess up a bit when writing equations.
Well, Iran, I feel like you don't fully understand it. You want me to go it over again?
Yes, sir.
All right, so Iran, they are asking us to write an equation in S, D, and N to show the relationship between the sticks and the dots. So how is the sticks and the dots related? How are they related? So let's run through it together, right? So, Aaron, when n is equal to 1, what is the difference between the numbers 6 and dots?
It's 0, sir.
When n is equal to 2, what is the difference?
It's 1, sir.
When n is equal to 3, what is the difference?
It's 2, sir.
So when n is equal to 4, what do you think the difference is?
T will be equal to 3.
So here what I'm saying, right? Do you understand that the number 6 is always like other than n is equal to 1. If you look at n is equal to 2, n is equal to 3, n is like getting bigger than the number of dots,
Yeah,
right?
it's staying up by 1, sir.
Yes. So here what I'm going to write. I'm going to say that the number of sticks plus the difference is equal to the number of dots, right? But get this. When n is equal to 1, what is the difference?
When n is equal to 1, the d is equal to 0, sir.
Right. So in other words, I would need to write n minus 1.
On -1.
Right. Because when n is 1, difference is
0.
right. Do you understand how I came up with the answer?
Yeah, sir. We'll see it.
Right. And when n is 2 now, 2 minus 1 is
2 minus 1 is 1.
right. Think you understand that then,
Yeah, I get it.
right? Cool. So that's a tricky question. Tricky. I had to like think twice. Tricky. Okay, let's move on now. Right? Look at January, look at me, January 2024 now. Okay. Right. Iran, let me do this question one time, right? What do you think the
Yeah.
next one would look like? So if you notice, 3 over here, right? So 1, 3, right? Then 1, 3, 5.
It'll be
So wait, let me observe a little pattern here. So 1, 3, 1, 3, 5. Then 1, 3, 5 what?
How much is that, sir?
So 1, 3, 5, then.
7
So I think that the next one would have
will be
1,
9.
1, 3, 5, 7, 9. That makes sense?
Yeah, sir.
So far they drew 1, 3, 5, 7. Yeah?
Yeah.
So this is what I'm gonna do. Okay. And if I confuse you, you could tell me, right?
Mm-hmm.
Right? This one, give me a second. Right? Okay. So we need it to work out in a way such that we'd have 1 here, 3 here, 5 here, 7 here, and 9 here. Understand?
Yeah.
So I have the 1 here, right? I put out 1 here, right? I need 3 over here, right? I need 5 over here, right? I need 7 over here. Right now we have 3, 4, 5. Okay. I need 9 over here. Right now we have 3 and 3, 6. I need 1 more. Right? And 2 over here, 2 over here, 2 over here.
So why ain't just add one on like each side? That could work or no?
Now, you need to add, okay, starting from the top, you put 1, and then from all the others, you add 2.
Yeah, but like if you put like one on each side, so like in the second row you could, since that one in the middle, you could add one on each side and it would kind of be even.
But you need to have, but how we working out, right? Is that there's 1 here, 3 here, then 1, 3, 5, right? Then 1, 3, 5, 7. So the next one would need to have 1, 3, 5, 7, 9. So if you add 1, it's not gonna,
No, I understand what you mean. Like how you had two, how you draw two on like one side, right? With people
oh,
and
like that.
instead of yeah,
That. Oh, yeah, yeah. You can do that. You can do that as well. That's fine. Mm-hmm. I understand. Right. All right. So do we understand this? I'm gonna get
yeah.
here and you understand
Yes,
this?
I get it.
So you understand that you just need to draw this in a way such that we'll have 1 here, 3 here, 5 here, 7 here, 9 here, and 9 and all the rest. That's what we're looking for. You good? Come on if you're okay with
That's
this.
it. Yeah,
And
sir.
and if you wanted, well, you could have do one on either side like that. That would have been fine as well. Right? Okay. Good. So let's move on. Right. So Aaron, let me go here, right? Let's go. So this one seems to be a little more tricky, but let's see how it's gonna go, right? So the number of white counters W, the number of black counters B, and the total number of counters T that form each shape follow a pattern. The values for W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. All right. So, Aaron, if we look over here, right, we can see that 1, 2, and 3. They're just talking about n, right? Seeing that? The 1, 2, and 3 here,
Yeah, sir.
that's just n, right? Right? Again, you see the 1, 2, and 3 here, that's just n, right?
Yeah.
So tell me the general formula then.
It'll be n plus 1, 2 n plus 1.
Okay, is there anybody that did not understand that?
No, sir.
All right. What about over here? What is, if you notice, it's in one
N plus 1 squared, sir.
right, n plus 1 squared. I think everybody understands that. Slightly different from the regular pattern, but not hard at all. Right? How would I figure out what this row is?
Well, so since we already have the 45, it'll be 4 plus 1 squared, which is equal to 25.
Great.
And then it'll be 45 plus 25 to get the total number of counters.
Exactly. Because watch, the total number is just the number of white counters plus the number of black counters. So 15 plus 9 is 24, 28 plus 16 is 44, 45 plus 25 is 69. No, 70. Yeah, just verify that, right? 70.
Yeah, 70, sir.
All right, do you all understand that? Yes or no?
Yes, sir.
So now, Adika.
Yes, sir.
I understand.
Okay, good. Now, if I need to figure out the number here, right? There are two ways you could do it. You know that 144 is equal to n plus 1 squared, so you can find for n using that method. And you know that 420 is equal to this. But I don't think you want to do this method because you'll have a quadratic you'll have to solve.
Also, to find the number of white counters, can't you just say 420 minus 144 to give you the answer here?
Oh yeah, I wasn't thinking about that. That real simple boy. I wasn't thinking about like that. Dude. Like I would let me show you what I would do, right? I would have just say, 144 is equal to, or I say n plus 1 squared is equal to 144, right? Find the square root on both sides. So you'd end up with n plus 1 is equal to 12. Move across the n. 12 minus 1 is 11. So I would have found n to be 11, right? Then I would have plugged it in over here. And that would have been 11 plus 1, right? 2 by 11 plus 1. And I would have gotten 12, 22 plus 1, 23. And 12 by 23 is what?
276.
Right, which would be the same answer you'd get, if you said 420 minus 144, right?
I mean, so you could still use this method here with the n plus 1 squared is equal to 144 to still find for the first blank. So even if you do the subtraction.
Yeah. So you understand this?
Yes, sir.
And just for the plot, right? Just for the plot, do you think you guys would have been able to figure out that n was 11 using this? Like using this method? Aaron, be honest.
No, sir, I don't think I would have bothered with that, so I might not to figure it out.
Let me see, right? So 3n squared plus 5n plus 2 is equal to 420. Let's move across the 420. If I move across the 420, I'm going to end up with 3n squared plus 5n, right? Plus 418, no, minus 418. Because if I move across positive 420, it's going to turn to minus 420. Minus 420 plus 2 is minus 480. I'm going to if you understand that.
Yes, I get it.
Now, let me use the AC method, right? So the A term here is 3, and the C term here is minus 418. What is 3 by
Yeah.
minus 418?
Which 3 minus 418?
Huh?
Yeah, Alex was 3 minus 418, sir.
3 by minus 4, I multiply them because we use any
Oh.
AC method. Yeah, what's 3 by minus 418?
I got minus 1,254.
Minus 1,254. 200.
254.
Now, we want to figure out two numbers that would multiply to give you minus 1254, but add to give you
5?
yeah. We already know that one of the answers is 11, right? So how much times 11 could go into minus 1254?
I got minus 114, so
I wonder if they did, like, if they carefully did the calculation, you're supposed to get the correct value for n, but if CXC just like put a number there, right? Then it would not work out.
what I realized is CSEC will just throw a set of big numbers there to try and confuse you, even if they don't really know what it means.
I feel so because let's use our calculator to actually find the value of n if you solve that quadratic. But I'm saying if they did carefully think through the question, you're supposed to get n is equal to 11 and some negative number, right? As the linear factors. Calculator, come on. Come on. Why does a virtual calculator take so long to come on? It's my question.
You need to get physical ones, don't take long to come on that.
Yeah. There's a second degree polynomial, 3, 5, and again, w minus 418. Oh no, look, it does work out. X1 is 11, and X2 is minus 12.6667. Yeah, so look, it does work out. It's just that it seems like it would not be able to. In other words, it'd be very hard to factorize.
Yeah.
That's what I'm saying. It'd be very hard to factorize. But if you solve for this using the quadratic formula, you will get 11. So they did carefully think about it. That's good on CX's behalf. Right? So let's take a little side quest to use the quadratic formula, shall we? A is equal to 3, B is equal to 5, and C is equal to minus 418, right? Do you remember the quadratic formula?
Is it minus b plus or minus the square root of b squared minus 4ac over 2a?
Right. Let's do this thing quickly, right? So that'll be negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 by a is 3, c is minus 418, all over 2 by a, which is 6. So that'll be negative 5 plus or minus, right? 25 minus 4 by 3, right? Minus 418.
I
Right?
got 71, so the square root. I did the square root one time.
Okay, would and that'll be 17 again?
No, I got 71.
71? Okay. Can't be 17. 17 way too small. Right. So your positive answer would be x is equal to negative 5 plus 71 over 6. We're getting for that. It's
That's
supposed
how I get 11.
right. Right. And the other solution will be negative, so that would be invalid. Because you can't have a negative number counters, right? Can you?
No, sir.
No. Let me know if you understand this.
Yes, I get it.
And we should not use x, we should use n because the variable there was n. So yeah. Okay, word. So guys, I just took a side quest over here, right? I just took a side quest over here. Realistically, I would advise you to use n plus 1 squared to find for n here, right? Because n plus 1 squared would be equal to 144, right? You're trying to find for n, so you need to square root both sides. If I find the square root of n plus 1 squared, the square and the square root cancels off. That leaves me with n plus 1, right? So n would be equal to 11 if I move across plus 1. Does everybody understand how I got n here to be 11? Yes or no?
Yes, sir.
Yes, I get it.
Yes, sir.
And if n is 11, I could just plug it into this to find for this. Or what you could have done, right? What you could have done, you could have just subtracted 144 from 420 to figure out the number of white counters. Why? Because this is the total number of counters. That's the combination of white and black. Yeah. Is everybody okay with this question?
Yes, sir.
Yes, sir.
Good. So the expression for the total number of counters, T is equal to W plus B in shape S is given by T is equal to AS squared plus BS plus 2, where A and B are both positive integers, just positive numbers, right? By substituting suitable values for S, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equations A plus B is equal to 8 and 3A plus B is equal to 14 respectively. All right. Okay, so by substituting suitable value for S, show the total number of in shape 1, total number of counters in shape 1. All right. So T is equal to W plus B, and they are telling us that for shape S, it is T is equal to AS squared plus BS plus 2, and they are telling us by substituting suitable values for S, right? S would just be the shape. Show that the total number of counters in shape 1, right? So shape 1 and shape 3 is represented by A plus B is equal to 8, and 3A plus B. Right, so Aaron, you still alive? I tell you,
Yes, sir.
looking hard, right? But let me give it a try. I promise it's not that bad. Not that bad. So by substituting suitable values for S, okay, show that the total number of counters in shape 1. All right, so let me see how I would go about this. So shape 1, right? Let's look at shape 1. What is shape 1?
Shape 1 has 6 white counters and 4 black counters.
Right? So for shape 1, right?
Yeah,
The total is what?
is 10, sir, 10 total.
Okay. And for shape 3, the total number of counters is
Um, 44.
hmm, and the total number of counters, right? Shape 1. Shape 1 would be represented by T. Hmm. Shape 3. So here what I would do it, I would solve this thing simultaneously, figure out what A and D is, right? And figure out something. I'm gonna do that. That's the only thing I could think of at the moment.
I thought we were going to do a simultaneous equation initially. So
Same, like, but then I read all that. Let me solve this thing simultaneously and see what happens. So you know you have a plus b is equal to 8, and we have 3a plus b is equal to 14, right? Elimination is the best move to make here. If you notice,
they are like terms, the two B's.
so just minus, right?
Yeah,
A minus 3a is minus 2a
2A
plus 0. 8 minus 14 is what,
equal to -6.
right? So negative 2a is equal to negative 6. So I would divide both sides by negative 2, right? So a would be equal to 3. Let me know if you understand that.
Yes, I get it.
And to find for b now, I would just use equation 1. So I would say a plus b is equal to 8. I know that a is 3, so 3 plus b is equal to 8, right? So b would be equal to 8 minus 3.
-3.
So b would be equal to 5. So if this is the case, then my expression becomes t is equal to, it becomes t is equal to a, no, I know a is 3, so that'll be 3s squared, right? Plus 5s plus 2, which is just this. Interesting. Okay. Show that the total number of counters in shape 1 and shape 3. Okay. So what if for shape 1, in shape 1, s would be equal to 1. So I think in t would be equal to 3 by 1 squared plus 5 by 1. Well, we're not going to end up with an equation. We're not. This is interesting. Let me think. But I don't think the solution is 3 and 5. Let me think. The expression for the total number of counters. A squared. Right. Yes. If I put 1 squared. Okay, I think I have it. I'm gonna try something. All right, so Aaron, you see what they talk about shape 1 and shape 3?
Yes, sir.
So I think in here what, right? Here what? For shape 1, right? What was the total?
10, sir.
Yeah, for shape 1, 10 was the total, right? Okay. And I'm gonna plug it into this, right? So you know that T is what? What's T? T is what? Remember, T represents total.
Oh,
So T is what?
this 10, sir.
Right, T is 10. Right? And if it's shape 1, S would be what?
Um, 10 squared.
No, no, no. I figure it out. But let me just explain it back from the start, right? So you see how they're talking about shape S, right?
Yeah.
And it told us to use shape 1 and shape 3. So if we're talking about shape 1, what do you think S would be here? If it's shape 1, what do you think S is going to be? Okay, so shape S, shape 1. What do you think S is? Okay,
Shape 1, sir.
shape number 1. Right. So for shape 1, S would be equal to 1, and the total was 10.
10.
So if I plug it into this, right, I'm going to get 10 is equal to A, right,
1 squared?
squared, right, plus B, 1 plus 2, right?
Yeah.
What is 1 squared?
1.
What's 1 by E,
1A.
Well,
right?
A,
E by 1,
B,
1B.
right? And you should probably be seeing it already. That kind of looking like A plus B is equal to 8. Because you know,
Yeah.
if I take this 2 and I move it across, that 2 and I turn to what?
minus.
Minus 2.
So 10 minus 2 is equal to A plus B. So in other words, A plus B would be equal to,
8.
yeah, it's okay. So you prove 1, right? Nice. Prove 1. Shape 3 now. If we're dealing with shape 3, what's S?
3.
F is shape 3, sir.
And what's the total for shape 3?
44.
44, right? So T would be equal to 44. Great. So I'm going to plug it into this, right? So what is T,
T is 44.
44.
right? And what is S,
3 squared.
3.
right? 3 squared. What is S again,
3.
3.
right? Okay. So 3 squared is what? What is 3 squared?
9.
You
That's
get 9A,
right. And that'll be plus 3B,
3B, plus 2.
right? I want to figure out, I want all the unknowns to one side. So A and B on one side. So you see this 2 over here? I'm going to take it. I'm going to move it across. So,
So it'll be 44 minus 2
right, is equal to 9A plus
plus
3B.
3B.
44 minus 2 is 42.
42.
So I'm going to end up with 9A plus 3B
3
is equal to.
equals to 42.
Are you all seeing any common multiples? Like, are you all seeing any common factors, right? Is there anything I could divide 9?
Yeah, you could divide 9A and 3B by 3, sir.
Exactly. So all of them have a common factor of 3.
3
So if I divide everything by 3, I'll end up with 3A plus
plus
B is equal to,
14.
yeah, that's the answer. Interesting question, though. Very interesting question. Yeah, it's very interesting. I like it, though. I like it. It's a nice question. So, like, let's see how, like, I was like, how to do this thing. But see, I didn't give up. I had to develop that mindset, right? I had to develop that mindset. Like, it might take a little while, but just make sure we're reading, making sense. And like if you had to recalibrate sometimes, it's fine, it's fine. But just keep a good mindset, right? Don't get negative, don't feel the bum up the world, and eventually you'll get the answer. Eventually you'll get the answer. Don't bum up the world, right? Don't get heated. But like, Aaron, you understand how I get the answer?
See how you
Yeah.
go.
Darius, what about you?
Yes, sir.
Okay, we would now feel like most of it, I just leave this question out. Yeah.
Yeah,
That is
sir.
one
Yeah,
of those
sir. I
questions.
would have leave that question out. I wouldn't stick around long enough to figure out like how you did. I would have leave that question out and forget about it.
This is one of them questions I might have just underline the information, spread it out, and then when I realize I can't do it, I will leave it out and come back when I finish.
But like, okay, like the question sound weird, right? When you read it, it sound kind of weird. Like they're saying the expression for the total number of counters T is equal to W plus B in shape S is given by T is equal. Like if you just read
Yeah,
that,
that part, when they say shape S, that confused me.
but like shape S is just be
Yeah.
normal, right? So like later on they talked about shape one, so S would be one because they said by substituting suitable values for S, show that the total number of counters in shape one and shape three is that. So if they're talking about shape one, S will be one. If they're talking about shape three, S will be three. And we already know the total number for the shape one and shape three. We
Right.
just had to put it into this equation now and prove this. Very tricky question. I'm curious to see what was the number of students that figure out this question this year. Yeah, very interesting. And it's 2 marks as well. That's crazy. I wouldn't say it was that hard. I just feel like the wording kind of tricky. Yeah, it's one. If you like you don't figure out this and if you're writing this, yeah. You see now? Right. So I hope all you could I hope all you're seeing how to go about a question in the exam. Like, if you don't just leave it out. Do all the easy questions first, come back to it, lay out all the correct information, and just make sure whatever you're doing makes sense. If it's not making sense, just stop it. Stop it right there. Like you would have seen had some moments where I just stop it because like I didn't see no future in that. Do that. Whatever you do, make sure it makes sense. Right?
So you had ever find out more about them deciding to have the exam on computer instead of physical copies?
No, I forgot. I'll be real honest. I forgot. After this session, I just like I was like stay awake a little bit in case someone message me, and I just fall asleep. Yeah. So I completely forget about that. I will hopefully remember after today. Hopefully. Hopefully. So we okay with this, right?
Yes, sir.
I'll call that a day when it comes to pattern and recognition. So what we're gonna do now, I'm gonna give all a 10 minutes break, come back, and we're going to move on to area and volume, right? So at 4:13, come back, then move on to area and volume. Yeah. All right, guys. Let me know if you're back.
Yes, sir.
All right.
Yes, sir.
Good. Area and volume now. Ah, right. Darius, I see you come around, boy. When I went so, boy. Away, boy, Darius, boy. Darius sticking, boy. Wait. All right. Huh? All right. Okay, now this in this year they already have a kind of question I want to do, right? In this year, I think we did this question already, did we not? When we was doing trigonometry.
Yeah.
Yeah.
Right, so let me check out what we have in January. Okay, these are the types of questions I'm talking about, right? Here we go. All right. So Adika, you there?
Yes, sir.
Adika, get this a read for me.
In this question, use pi as 22/7. A piece of wire 61 centimeters long is bent to form a sector, as shown in the diagram below. The sector of the circle OPQ has center O and a radius of 18 centimeters. Show that the value of x is approximately 80 centimeters.
So that's a little tricky, and little tricky, and
Kind of.
all right. So first things first, right? What is the length of wire you're bending to make a sector?
61 centimeters long.
Mhm. And if this is a sector, right? Remember, a sector is a piece of a circle bounded by two radii. So if this is 18, what would this be?
18.
Right? And if the entire wire was 61 centimeters long, would it be possible for me to figure out for the arc length?
Yeah.
What would the arc length be?
18 plus 18, and then you take away the answer from 61.
Right? And what would you get?
25.
Right. So hear what I'm saying, right? The arc length for a circle, do we all agree that the arc length is just piece of the circumference? Yes or no?
Yeah.
Right. So the arc length is just going to be the circumference. What's the formula for circumference? Does anybody know formula for circumference of a circle? Right. You need to remember this, right? So if you want to figure out the circumference for a circle,
Pi r squared.
nah, not pi r squared. The
2
circumference,
pi r squared.
yeah, not 2 pi r, no squared, guys.
2
Anytime
pi r.
squared, anytime you see squared, that is area, yeah? Not, nah. Circumference is the same thing as perimeter. That's just the distance around the circle. So circumference is 2 pi r, right? The area is pi r squared. And if we are talking about a sector, well, they would say that the arc length is just the circumference, right? But a fraction of the circumference. So the arc length is 2 pi r multiplied by multiplied by theta over 360, where theta is the angle. Guys, try to understand something, right? Adika, A full circle is how much degrees?
360.
And an arc would be some portion of 360, and like if you look at this,
Yeah,
it's like some piece of 360.
yeah.
Yeah. So I'm saying the arc length is just the circumference, but it's a fraction of the circumference. Can you see that? If this is the whole circle, can you see that the arc length is just a fraction of the circumference?
Yeah.
Okay, so I'm saying that the arc length is just equal to 2 pi r all over 1 multiplied by theta all over 360. And in this question, we want to show that the value of x, which is the angle, right? The angle here is theta, is 80 degrees. So I'll just call this x, right? And x is the angle. So let's plug in everything that we know. So tell me, Adika, what is the arc length? Do we know what the arc length is?
25 centimeters.
Right, so the arc length is 25. They want us to use pi as what?
22/7.
And what's the radius?
18 centimeters.
Right? And we're going to multiply that by x all over 360. Right. All right, so I want you to work out the top for me. Multiply everything here and tell me what you get. So 2 by
So I
20,
get 113.14.
I got 113.14.
right? So here what? I would advise you to leave it as a fraction, right? To get the exact value. So that is 792. Actually, you would get the exact value, but I feel like right now, it's like real close to the exam. I feel like most of you would be a lot more comfortable with decimals. Yes or no?
Yes, sir.
Okay, so we'll use decimals, right? So that'll just be 113.14. 113.14. Okay, right? Over 1 multiplied by x all over 360. So if I were to multiply this out, right, Adika, it'll be numerator by numerator. So that would be 113.14 x, and in the denominator, that would be 1 by what?
360.
Right.
60.
So I'm going to cross multiply here, right? So I could write 25 as 25 over 1. If I cross multiply, what am I going to end up with, Adika?
9,000 for 25 times 360.
Right. But I'm going to multiply this out first, right? So I can get x on the left-hand side. So that would be 113.14 x. And why did I say that? What is 1 by anything, Adika? What is 1?
It's
What is 1 by
Anytime.
exactly, right? So we get 113.14 x, and then we need to multiply 25 by 360. What is 25 by 360?
9,000. So
Let me verify that. 360 by 25. Yeah, again, 9,000. So Adika, what would I have to do on both sides if I want to find for x now? Adika, no, you guys. Adika, I want to find for 1x. What would I have to do on both sides?
Divide by 113.4.14.
And I should get approximately what?
Um,
Look at the question.
80.
Yeah, I should get approximately 80 degrees. So plug into your calculator and let me know where you're getting.
79.5 centimeters. If you round it up, it will be 80.
Right. Right. So 9,000 all over 113.4.14. You get 79.5, right? And which would be equal to 80 degrees, right? To the nearest degree, right? Okay, do we understand how I did the question?
Yeah.
Yes, sir.
Okay, good. So let's just summarize, right? Guys, if I ask you for the circumference of a circle, what's the formula for circumference?
2 pi r,
Pi
sir.
r.
Right, 2 pi r, right? What is the formula for arc length? Remember, arc length is just a fraction of the circumference. Guys, hear me out. Darius is
360 minus 2r.
no. Hear what I'm saying, guys. Hear what I'm saying. The arc length is a fraction of the circumference. What is the circumference, guys?
2 pi r.
Right. And I'm
It'll
saying,
be 2 pi r over 1 times x over 360, sir.
yeah, where x is the angle. Because an arc length comes from a sector, right? And a sector is just a piece, a slice of a whole circle, right? And so what? Let me show you what we're talking about. Guys, can we see that as a full circle? How much degrees is a full circle?
360.
360.
So 360 degrees, right? So if I cut a piece, a slice out of this circle, wouldn't this angle here be a fraction of the 360?
Yes, sir.
Yeah. So arc length is just a fraction of the circumference. So a full circle is 360. So that's why I'm saying x over 360 by 2 pi r. Alternatively, it could say theta, right? But x and theta represents the angle. Do you all understand this?
Yes, sir.
Yes, sir, I get it.
Okay, well, tell me, what is the arc length? What's the formula for that? Is what?
Circumference over 1 multiplied by theta over 360.
And if you forget, just remember, a full circle is 360. Don't, you can't forget that. All right? Good.
Yes,
What
sir.
is the formula for area of a circle? Area of a
R
circle,
squared.
right? Area of a circle is pi r squared. Good. We understand that?
Yes, sir.
Yes, sir.
Okay, good. Let's move on. Calculate the area enclosed by the wire. Now, guys, we just established that a sector is fraction of a whole circle, yeah? Yeah?
Yes, sir.
Yes, sir.
Remember, guys, what's the area of a full circle?
Pi r squared.
Pi r squared.
And a sector is just a what?
A fraction.
A fraction of the circumference.
Exactly. So, guys, the area of the sector, I'll take a guess. Try to come up with the formula.
Will it be pi r squared over 1, sir?
Pi r squared over 1, right? Multiply by. Remember the area?
By
Theta over 360.
Yes. I just write x here to keep consistent. Can anybody tell me why it's x over 360?
Because our full circle is out of 360 degrees.
And a sector will be?
And a sector is a fraction
This
of
is the
this
part of fraction.
circumference.
Exactly. A sector is just piece. It's like a small, it's a fraction of the full circle. Watch. Again, if you're confused, if I draw a circle here, right? Can we see that
Yes,
this
sir.
is just a fraction out of 360?
Yes,
Yes,
sir.
sir.
Okay, good. Right, so the area would be equal to 22 over 7. My radius is 18, right? All over 1, right? And I'm multiplying that by my angle. Where's my angle again? What was the angle for x?
80 degrees.
So plug this into the calculator, I'm going to weigh it. Let me plug it in as well. So 22 over 7, right? 18 squared multiplied by 80 all over 360. And you're supposed to get,
I get 226.285714.
right. So that would be 226.29,
29.
right? And the units for that is going to be centimeters squared. This is I'm finding the area, right?
Yes, sir.
Right. I don't know if you guys understand this.
Yes,
Yeah,
sir.
so I get it.
Right. Now, January 2025 was one of the harder years. I'll just say that. So the questions you're
Yeah, it was.
not going to see easy questions. You're going to see kind of hard questions. Right. So let's move on. So Adika, if I ask you what the formula for area of a circle is, what's the formula for area of a whole circle?
2 pi.
Nah. It's a circumference. Area of a circle. I'll help you out, right? So area of a circle is pi r squared. You were telling me circumference. What's the formula for circumference of a circle? Tell me, Adika, what's the formula for circumference of a circle?
2 pi r.
Right. And if we are dealing with arc length, remember arc length is just a fraction of the circumference, right? So you tell me what to write for arc length. Think of it logically. So it'll be 2 pi r multiplied by
X over 360.
right, because an arc would have an angle, right? And it's referenced to a full circle, and a full circle is 360 degrees. So the arc length is 2 pi r multiplied by x over 360, where x is the angle, or theta. Right. Could you tell me the area of a sector? How would I find the area of a sector? Run material. How would I find the area of a sector?
Pi r squared times theta over 360.
Right. Theta or x over 360. Because a sector is just a fraction of a big circle, right?
Yeah.
Great.
Sir.
Right. So who wants to help me with this question now?
There you go, sir.
All right, well, Darius, get our read for me.
A cylindrical block of cheese has a radius of 12 centimeters and a height of 8 centimeters. The cheese is divided into equal slices. The uniform cross-section of a slice of the cheese is a sector whose angle is 18 degrees, as shown in the diagram below. Calculate the length of the arc AB.
All right, do you have any ideas?
You gotta use the formula for the circumference.
Not quite. Do you remember the arc length formula? Darius, the arc length is a fraction of the circumference. Remember that? Arc length is
2 pi r over 1
multiplied by
multiplied by theta over 360.
right, where theta is the angle of the sector, right?
Yes, sir.
So in this question, they want us to use pi as 22 over 7. So I'm gonna in the next line, I'm gonna say 2 multiplied by 22 over 7. What is my radius?
12.
12, right?
Yes, sir.
And guys, you don't really, you see the thing is, right, you don't have to write it over 1, right? You're just making it look complicated. You don't have to write 2 pi r over 1, right? Because Darius, would I write 5 over 1? Or would I just write 5?
No, sir.
Just write 5.
5.
What's the angle here?
18 degrees.
Right. So 18 all over 360. So plug that into the calculator and I'm going to make it for the calculator.
Get 3.7714,285. So
Let me-
3.77.
Let me just verify that. Yeah, 3.77, right?
Yes, sir.
3.77 centimeters. All right. So guys, Adika, do you feel like you understand that or not?
Yeah, I understand it now.
So Adika, you understand that if you want to find the arc length, it's just the circumference of the circle multiplied by the fraction. And the fraction is just the angle of the sector divided by 360. So Adika, for this shape, what was the angle of the sector?
18
Right.
degrees.
That would be 18 over 360. Right? So you just find the circumference and multiply it by 18 over 360 to get the arc length. Right, so let's move on. Yes, so Darius, read part 2 from her.
Determine the area of the curved face ABCD.
Okay. Right. Darius, I promise it's easy, right? I promise. Promise.
Promise me.
So Darius, do you understand that, area is just the product of two dimensions?
Yes, sir.
Okay, so what's this dimension over here?
8.
Right, this is 8. And what is this dimension over here?
18 degrees.
No. Angles are not lengths, sir. We actually just found it. 3.77.
3.77.
Understand? Or we just not
No.
arc length.
Oh, okay. Okay. Wait, yeah. It matters now.
Because watch, this is our sector over here. And this is the arc.
Right.
We just found for the arc
Right.
length.
Yes, sir.
Right? So we just found for this. And we found that would have been 3.77. You know, let me know if you understand that.
Yes, sir. Yes, sir. I understand.
And they want us to figure out the area of the curve face ABCD. So to find that
Right.
area, okay, this shape can look like a what? What does it look like?
Square.
A
square.
square.
It's not a square, it's a rectangle. But to find the area for that, it's just going to be 3.77 by 8. That's it.
Right.
So area of ABCD, that would be equal to 3.77.
Multiplied by 8.
So I'm going to use the
Negative
exact,
About
30.16.
30.16.
if you use the exact value, you get 30.17. If you use the exact value.
But so I did, and I got 30.16.
That's interesting. Let me try that back again then. 2 multiplied by 22 over 7 multiplied by 12 multiplied by 18 over 360 right? I get in the 3.77 and I multiply that by 8. Again, 30.17. Like if you use the exact value, like the 3 point whatever, you'll get 30.17.
So I did. I used 3.77 times 8 and I got 30.16.
No,
I
but
put it in like that, like how you have it there.
like I talking about 3.7714, like the full answer, you know?
Oh,
Yeah. So what I did, right? I actually use the exact answer, not 3.77. 3.77 is your rounding off answer. If you use the exact answer from the calculator, right, you're supposed to get, yeah,
3.17.
yeah, 3.17. No, not 3.17.
No, 30.17, my bad.
Yeah, 30.17. What mark this is? A 1 mark question. They wouldn't take away the mark. Right? They wouldn't take away the mark. Right? Let me know if you guys understand that. So
Yes, sir.
effectively a rectangle. So 3.77 by 8. Yeah, answer. Salma, Adika, you understand that?
okay, I got 3.17, so
Okay, good. Adika, did you understand how I got it?
Yes, sir.
Okay, good. So part 3. Given that the area of OAB, right, OAB is 22.6, evaluate or calculate the volume of the entire block of cheese. Right. So they are telling us that the area of OAB, right? Okay. Guys, does anybody in here know what a prism is?
Yes, sir.
Prism
I
is,
know what the prism is.
what is a prism?
It's like the 3D version of a triangle.
Now,
Like, when I say I know what a prism is, I mean I know what it looks like. Like,
okay, a prism is a shape whose cross-sectional area is the same. So like, when I explain, right? So imagine you had a knife here, like you slice it. No matter where you slice it, you're supposed to see this. It's the exact same shape. You understand what I mean?
Right.
So like,
Yes, sir.
if I slice it along here, right, and I look down, I'm supposed to see this exact shape. That's what a prism is. And anytime you're dealing with a prism, the area of any prism, I'm saying the volume of any prism, so volume of any prism is just simply the cross-sectional area, right, multiplied by the height. So guys, can we understand that this is the cross-sectional area? Like if I cut it, like if imagine if you cut this, if you cut it, wouldn't you see this?
Yes, sir.
Like when I say cut it, right? Imagine like you slice it like that. Like you slice it like that. Like imagine this is it, right? Imagine you take a knife and you slice it, and like you slice it, like you slice it, and then you look down. You would see the same. You would see the same thing. The same thing. So what I'm saying is, I'm saying that the top area here, this is the cross-sectional area, and you see this 8 centimeters here. What do you think that represent? Tell me that.
height.
Yeah, that would represent the height. So in the last part, they actually just put on some labels here. This is O, this is A, and this is B, right? So in the last part, they are telling me that the area of OAB, which is the cross-sectional area, is 22.6, right? And they want me
Right.
to calculate the volume. Darius, put one on one together and see if you can figure it out. What do you think the volume would be?
Volume would be the
It'll be
the
22.6 times 8, sir.
Darius, do you agree?
yes, sir.
It's something unsure, right? But Darius,
Yeah.
for any prism, again, here what I'm saying is a prism, Darius. A prism is a shape. Once you cut it, you'll get the same cross-sectional area. Imagine this is a cake, right? And I'm not talking about slicing it like down, right? I'm not talking about like down. I'm talking about you cut
Yeah,
it across, and then you look.
cross. Yes, sir.
You will always see this area. So what I'm saying is, if you want to find the volume, it's this area over here multiplied by the height. And in the question, told us the height was
8 centimeters.
right.
I got 180.8, sir, as the volume.
I was going to tell them this example over here. So Darius, for it to make more sense here, right? What kind of shape is this?
Yes, sir.
These are what?
Rectangle.
Now, what was the name of this three-dimensional shape?
Oh, a cuboid.
Yeah, this is a cuboid, right? Now, can we both agree that this is made up with a bunch of pages? Bunch of pages.
Right. Right.
Can we see that all of the pages are the exact same area?
Right.
So here what I'm saying, right, Darius? If you find the area of one of the pages, right,
Right.
that would be the cross-sectional area, right? Because no matter how I open this book, all of the pages, they have the same area, right? So I'll find the area of
Right.
one page and I'll multiply it by the height. And that would give me the volume.
Right.
That's the concept.
Okay, sir.
It's the same
Yes,
thing,
sir.
right? This is the area, this is the height, volume is just the product. That's it. So let me know what you got for that.
180.8.
Let's see. 22.6 by 8, 180.8, yes. And since it's volume, Darius, that'll be centimeters what?
Centimeters cube.
Right, centimeters cubed. Right. Okay, so here with Darius, for any prism, the volume is just the cross-sectional area by the height. For any prism. Okay, would you say that this is a prism? And remember, Darius, a prism is a shape that if you cut it, the cross-section will be the same everywhere, right? That's what a prism is. So tell me, would this be a prism? Like anywhere I cut this, if I look
Yeah.
down at it, would it still be the same area I'm seeing?
Yes, sir.
Yeah, so to find the area for this shape, I'm just going to find this area, which is pi r
By the
squared,
height.
and multiplied by h. That's why the formula for a cylinder is pi r squared h, in case you ever wonder, right? Because it's the cross-sectional area, right, by the height. Okay, what about for a cone though? You think a cone, if I cut this, right, into slices, will I see this, will I see the same exact circle?
No, sir.
No, so I would not call that a prism, right? I would not call this a prism. I mean, if you understand that.
Yes, sir.
Okay, would. All right, so let's move on. Right, so before we move on, right, Adika, I want you to remind me, what is the formula for circumference of a circle?
Is 2 pi r
Right. And if I wanted to find the arc length,
It will be 2 pi r over 1 multiplied by x over 360.
x is the angle of
The shape, the arc,
right, the sector, the angle of the sector.
or here.
Because the arc length is the length, outer length for a sector. Right? What if I wanted to find the area of a circle? Area of a circle. What is the area of a circle formula?
Pi
Oh, why am I yawning so much? Yeah, pi.
r squared.
Right, pi r squared. Yes. Right, and a way to remember it, right? And when you find an area of something, the units could be like meter squared or something.
Yeah.
Yeah, so r squared, meter squared. And do you remember how to find the area of a sector?
Um.
So same concept as the arc length, same kind of concept.
You multiply.
So wait, I have a question, right? Do you understand that a sector is just a slice of a circle?
Yeah.
It's saying that yeah, kind of unsure, but yeah, a sector is just like a slice of a whole circle, right? Can you see that that sector is just a fraction of the whole circle,
Yeah.
right? So a fraction of a circle would be what over what?
X over 360
Right?
multiplied by pi r squared.
Yes. Right. So please remember these things, right? Remember these. Right. So Adika, let's do this question together. So give it a read for me.
The diagram below shows a hemispherical
Hemisphere.
bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 centimeters, the height is 17 centimeters, and the radius of the bowl is r. Show that the volume of the cylindrical tin is 1923 centimeter cubed. Correct to 4 significant figures.
Specifically, right? Correct to four significant figures. So whatever answer we get, we need to round it off to four significant figures, right? All right. So, Adika, do you remember the formula for area? Area. I'll say area. Do you remember the formula for volume of a cylinder? Volume of a cylinder? Yes or no?
No.
Say that again?
No, I think you had to multiply whatever it is by 3. Like,
Nah. Let me show you a way to remember this, right? In the last question, right? In the very last question, how did you find the volume for the shape? You multiply the what by the what?
the
You remember what CSA stands for?
like the way cut it, like,
Right, cross-sectional area. CSA stands for cross-sectional area. For any prism, the volume is just the cross-sectional area by the height. So can we both agree that this is a prism, and why, no matter where I cut this, the cross-section is going to be a circle, yeah?
yeah.
So if you want to figure out the volume for this, you need to figure out the cross-sectional area and multiply it by the height. So what shape is the cross-sectional area here?
A circle.
Right. Do you know how to find the area of a circle?
Pi radius square.
Right. So area of circle is equal to pi r squared, right? So if they're telling us that the diameter, if the diameter is 12, right? What do you think the radius would be,
6.
right? And so if I want to find the volume the volume is going to be the cross-sectional area, which should be given by pi r squared multiplied by the, so think back to the example we just did. We multiply the cross-section,
height.
right, by the height. So pi r squared h. That's the formula for a cylinder, pi r squared h. So it's just going to be pi, they want us to use pi as 22/7. It's going to be 22/7, right? My radius is going to be what? If my diameter is 12, what's my radius?
6.
Right? So 6 squared. And what's my height?
17.
So plug that into the calculator and let me know what you're getting.
Just now, say a real big fraction.
All right. Yeah. That's it. Yeah, you're supposed to get 1923
Yeah,
because that's what they wanted to show. When they wanted to show
I
that,
get that. And 2/7.
right? So 22/7, right? 6 squared by 17. You should get over 7. Now you're supposed to get 1923.428571. Make sure you get in this. So your answer is going to be equal to 1923, right? Centimeters cubed, open bracket, correct, to 4 significant figures. Adika, you get any 1923.428571?
Yeah, I got that, sir.
Yes, yeah, so, well, I am my sharp, so I get the thing as a fraction. So I get 1923 and 3/7.
All right, let me tell you what to do to get this a decimal. If you want to get this a decimal, press ABC. Again, it's a decimal.
I'm trying to find the ABC. Oh, yeah.
Okay, good. Right. So we got that. Great. Right? So Adika, read this question for me now.
The bowl is completely filled with soup. When all the soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. Calculate the radius of the bowl. The volume V of a sphere with radius r is V equals to 4/3 pi radius cube.
Right. So Adika, it sounds scary, but we could do this, right? We could do this. So Adika, they say the bowl is completely filled with soup. I'm gonna ask that question. This is a hemispherical bowl. So can we both agree that this volume here will be the half the volume of an entire sphere? Or not? Hear what I'm saying, right?
Yeah,
Can you see that this is half of a sphere? A sphere.
yeah,
So the volume for this is actually going to be half the volume of a full sphere. So can you see that they gave us the formula for a sphere here?
yeah.
Right. Cool. Right. So so we need to come up with an equation for the volume of a hemisphere. Right? So the volume of the hemisphere, volume that would be equal to 4 over 6 pi r cubed. Now you're probably wondering, oh, where did I get the 6 from? If I multiply this thing by a half, right? And we just now established that the bowl is half of a sphere, right? And we can see that the bowl is half of a sphere.
Yeah.
We find half of this. 4 by 1 is 4, and 3 by 2 is 6. So 4 over 6 pi r cubed. I'm going to figure that.
Yeah.
It's all not sure. Like, it's not making sense. Come on, be honest.
No, I understand.
All right, Aaron, what about you? Do you understand that our hemispherical bowl is just half of a sphere, a whole sphere?
Yes, I see it. Yeah.
So it's just half of that entire volume formula there, right? So that's
Mhm.
of a hemisphere. Now they're saying when all this soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. Could somebody tell me what the full volume of the tin is?
1932.
Right. So Adika, let's write that down, right? So Adika, let's write that down. Full volume of tin is equal to 1923. Adika, do you understand that part? If I say that.
Yeah.
And now when I take the soup from the bowl and I pour it into the cylinder, how much of the cylinder gets filled?
90%.
Right. So could we figure out the amount of volume in the bowl then?
Yeah.
Right? Volume in bowl. How would I do that?
Um, Multiply 1923 by 90%.
Right. So I'll multiply by 90 over.
100.
Right. So plug that into the calculator and let me know what you get. So Aaron, so far you understand everything we're doing?
Yes, sir.
Okay. Nice.
1730.7.
Right. I'll use the value again. So 1923. You got 1730.7
Yeah.
centimeter cube. Great. So, okay, I have a question, right? Guys, if we know that that is the volume in the bowl, is it possible for me to form an equation in which I can solve for R? Yes or no?
Yeah.
Yeah, right? Volume. It is possible. Daria, see if you can figure it out. What is my next move from here? Daria, see if you can figure it out. So think, Darius, think. So Darius, remind maths, if you need to solve for something, you need to come up with an equation with one unknown. So
Yes, sir.
Darius, do we know how much volume um of soup there is in the bowl? Do we know?
Yes, sir. Yes, sir.
How much is that?
1730.7.
Right. And do I know the formula for volume of a bowl?
Yes, sir.
Yeah. Well, I say bowl, right? But it's really a hemispherical bowl. But the
Yes,
point,
sir.
Darius, we know what the formula for the volume would be for the bowl, right? If I want to find the volume, I'll use our formula. And I know how much is in the bowl. So is it possible for me to make an equation there?
Yes, sir.
Yes, it is possible. So what would I write then?
Um,
So what's the volume in the bowl?
the volume in the bowl is 1,730.7.
Right? And that would be equal to what formula?
Um,
What's the formula to find?
46 pi cube.
Right. Okay, say what, man?
Yes, sir.
Was the only unknown in this equation?
dr.
Right, so we need to find for R. First thing I'm going to do, I'm going to replace pi with 22 over 7. Right? What is 4 over 6 by 22 over 7?
Um, 44 over 21.
Could somebody verify that? Hey guys, can anybody verify that? Adika, could you verify that 4 over 6 by 22 over 7 is 44 over 21? Okay, I'm not hearing you guys at all.
Yes, I got that.
All right, so here we're going to do, right? Now I get the feeling that all you don't like working with the fractions, right? But like there's a problem with using when you keep using rounded off values. So I'm gonna take this opportunity now to show you all how to work with fractions. I'm gonna take the chance now. So guys, over here we have 44 over 21 multiplied by r cubed. That would work out to be 44 r cubed over 21. Okay, who did I confuse? Okay, Darius, did I confuse you? If I say this, will that really confuse you?
Okay, that way. Yeah.
Okay, let me ask that question, right? If I had 1 over 5 multiplied by 7, what would that be?
That'll be 1 over 5 by 7 over 5.
No, that would just be numerator by numerator over denominator by denominator. 7 is the same thing as 7 over 1, so that would be 7 over 5.
7 over 5.
Right, so if I have 44 over 21 multiplied by r cubed, then r cubed is the same thing as r cubed over 1, so 44 r cubed over 21.
Okay.
And I'm doing this so that we can cross multiply, right?
Yes, sir.
Okay, so let me cross multiply. If I cross multiply, I'm going to end up with 44r cubed and 21 multiplied by this. What is 21 multiplied by all of that?
So we got 36344.7.
I get
36344.7.
all right. Let me just verify that. All right, so 36344.7 And then the next thing I'm going to do, I'm going to divide both sides by 44. Right? And to find for r, I would just find the cube roots on both sides. So r would just be equal to the cube root of all of that. So plug that into your calculator and let me know what you're going to get. So to get the cube root, you're going to press Shift square root. And then you're going to put fraction button 36344.7, right? 44. Press E.
9.38.
Right. So that's the answer for R. Now, I feel like I didn't like this method. So I'll show you all some other approaches you could have taken, right? But truth be told, I don't see anything hard about this. I feel like they just really have problem with fractions. I feel like fractions are just stress people out, you know? So Darius, let me share another way to attack this question. Are you okay up to this point? Yes or no?
Yes, sir. Last, I think this method was good.
Okay, well, I'm going to share another way to do it. Fraction, so annoying. All right, so T. Yeah, so Darius, watch this, right?
Yes, sir.
If I wanted to get rid of 44 over 21, right? Wouldn't I have to divide by 44 over 21 for it to cancel off?
Yes, sir.
Now, if I divide by 44 over 21, it's the same thing as multiplying by. Here I was saying, right, Darius? You're looking real confused. If I divide by 44 over 21, if I change that division to multiplication, what happens to the fraction?
Yeah. It will flip.
Right. And if you don't believe me, watch this, right? Watch this. 44 over 21 multiplied by 21 over 44 is just 1. And you're probably wondering, why am I doing this? Watch, Darius. If I want to get rid of it, I would have to divide by 44 over 21. So it would cancel off and I
Right.
get. So as you can see,
Right.
if I multiply 44 over 21 by 21 over 44, it does the same thing. And you get anyone?
Yes, sir.
Right. So, and let me understand why. So Darius, for me to get rid of the 44 over 21, I would have to divide both sides by 44 over 21. Now, Darius, dividing by 44 over 21 is the same thing as multiplying by?
21 over 44.
Right. So what I could do is I could just multiply by 21 over 44 on both sides.
Okay.
And when I do that, on the left-hand side, it's going to cancel off, right? So that's just going to leave me with r cubed. So r cubed is going to be 1730.7 multiplied by 21 over 44. And to find my answer, I just have to find the cube root of that. So plug that into a calculator and let me know what you get.
So I get 9.38.
Yeah, the same answer, right? So it's really just which method do you feel most comfortable with? There's a bunch of ways to do the same thing in maths. I was kind of worried that if I show you this is my scale, I kind of showed you all this method because you know how to do cross multiplication already. But this is a much nicer method, in my opinion. So let me run through this question one more time because it was a lot of working for 3 marks. So Darius, they say in a bowl is completely filled with soup. So the bowl is completely filled, right?
Right.
Taking the soup in the bowl and pouring it into the empty tin. And they are saying it fills 90% of the tin, right? So Darius,
Right.
if it fills 90% of the tin, and we know that the tin is 1923, and to figure out the volume in the bowl, we would have just find 90% of the volume in the tin.
Yes, sir.
Because when you took what was in the bowl and you put it into the tin, it filled it 90% of the way. So 90%
Right.
of 1923 would be how much liquid was in the bowl. Make
Right.
sense?
Yes, sir.
And since it was completely filled, that would mean that 4 over 6 pi r cubed would have to be equal to the amount we found, right? Because this is why we would find the volume for the hemispherical bowl. So we made an equation, right? They wanted us to use pi as 22 over 7, so we did. And we multiplied it out, we got 44 over 21, r cubed is equal to that. Now, truth be told, I really prefer this method. What do you think? Or like you prefer the cross multiplication?
It was normal.
Okay,
I prefer the method on the right side.
same, right? Because it works for any fraction. I'll show you what I mean by just now. So we wanted to get rid of 44 over 21. To get rid of 44 over 21, you just simply multiply by the reciprocal, which is 21 over 44. So r cubed is just equal to this. To find for r now, do the opposite of cubing. Darius, what is the opposite of cubing something?
Cube root.
Right, so you apply the cube root on both sides and you get your answer. Bam. So yeah, let me show you a different example. Let me just say we had 95 over 76. X to the power 3 is equal to 71. Look how simple this is, Darius. All I had to do, multiply both sides by 76 over 95, right? X cubed would be equal to 71 multiplied by 76 over 95. From there, I can find cube root one time. Aaron, let me know if you understand this.
Yes, sir.
And
I
Aaron,
get it.
if you don't believe me, what is 95 over 76 by 76 over 95? Let's see. It's 1.
One.
Yeah. So do you understand that by multiplying by the reciprocal, it effectively gets rid of the thing that's by the x cubed or whatever the unknown is?
Yes, sir.
It would. And again, I was kind of worried to show you that trick, but I'm glad to see all you understand it. Right. Okay. All right, so this question now. So Aaron, let me handle this question, right? To give it a read for.
The diagram below points L, M, and N on the circumference of a semicircle with center O and a radius of 18 centimeters.
Right? What do they want us to do?
Calculate the total area of the shaded regions in the diagram.
Right. So guys, do you all think that if I have the area of this entire thing, right? If I find the area of the entire semicircle, right? Right? Let's just say I find the entire area, right? Aaron, what do you think will be the next step? If I found the area of the entire semicircle, what will be the next step?
To find the area of the triangle,
Right. And then what then do what to the both of them? Add them or subtract them?
add them together to find the total area of the shape.
Nah. They don't want that, they want the area of the shaded sections.
Oh,
So think about it. If you have the area of the circle, I mean the semicircle, and I have the area of the triangle, if I subtract them, can we see that the gray regions remain?
yeah, sir.
So that's exactly what I had to do. So first things first, they're telling us that we have a semicircle with a radius of 18, right?
Yeah,
So that would make O to N 18. That would make L to O what?
18.
And that would make O to M what?
Also 18.
Right. If you confuse what? O is the center and M is a point on the circumference. From circles, if you have a point from the center to the circumference, what do you call that?
A radius.
Exactly, a radius. Right. Great. Great. So first things first, let's find the area of the circle, the semicircle, right? Area of semicircle. Now a semicircle is just half a what?
That's a regular circle, sir.
Right. And how do you find the area of a regular circle?
2 pi r squared.
Nah, not
Sorry, pi r squared,
pi r squared, right? And I'm gonna multiply that by
a half.
right. So let's do that. And again, they want us to use pi as 22 over 7, yeah?
Yeah,
So it's gonna be 22 over 7. My radius is 18, so 18 squared multiplied by a half. So plug that into the calculator and let me know what you're getting.
I got 509.14.
Darius, confirm that.
Yes, sir.
And let me just confirm that as well. Yeah, I'm getting 509.14,
Two.
right? Centimeters. Right. Now, guys, if I want to find the gray regions, right? I just found the area of the entire semicircle. What do you guys suppose I should find for next?
The area of the triangle, sir.
Right. Now, what is the formula for area of a triangle?
Length, um, length by breadth divided by height.
Now, let me show you a way to remember this, right? Like for final. Okay, so imagine you had a rectangle, right? Imagine you had a rectangle, right? Wait. I'll show you how to derive the formula. Fast. Let me just say you had a rectangle, right? And let me just was base, and this was let me just call this base, and let me just call this height. If that was the case, what would the area of the rectangle be?
Height by base, sir.
Base by height, right?
Mhm.
If I cut a rectangle in half, what shape do I make?
A triangle.
Right. So the triangle is just a half base by height.
Oh,
Yeah. So area of a triangle is just a half base by height. Now, what is the length of the entire base here?
36,
And what is the length of the entire height?
18.
Right? So my base is 36 and my height is 18. So that should be 18 by 18. So like 256, I think. I'm not sure. No, 324. 324. Right? Just make sure again, 324. I'm only figuring
I
324.
got that, sir.
Right. And it should be centimeters squared, right? Because we find an area.
Yeah.
So guys, what would the shaded sections be now?
It'll be 509.14 minus 324, sir.
Right? 509.14 minus 324. And what would we get?
I got 185.14.
What about the rest of you guys?
Yes, sir.
And the units will be centimeters squared, right? Don't forget the units. Right, so that's the working for that. I want to do one more question like this, and then I'm gonna give probably a 15 minutes break. Come back, we're gonna do transformations. That's the only question I want to look at. This is the question. All right, so Darius, am I doing this question in the live or not?
Not so much.
Or you will do it my hair then?
I said, in this question, take pi is equal to 22/7. The diagram below shows a gold bar in the shape of a trapezoidal prism, and its volume is 2,886 centimeters cubed. The length and height of the prism are indicated on the diagram. Calculate the area of the shaded cross-section of the trapezoidal prism.
No, Darius. This is what
Oh,
kind
yeah, I remember that. I remember this.
well, I will see, right? Remind me. If it's a prism, right? If it's a prism, how do
Right.
you find the volume of a prism?
Um, the height by the area.
The cross-sectional area. So the volume of a prism is equal to the cross-sectional area multiplied by the height. Now, Darius, the cross-sectional area is the area that will be the same no matter where you cut. So, like, can we agree that if you had a knife here, right? You had a knife.
Right.
And let me just say you take it and you cut it a slice. You cut a slice.
Right.
What do you see?
It will be the same shape.
What is it?
You'll see the same trapezoidal shape
Exactly, right? Exactly.
across.
So this is really the what? The cross-sectional area, right? Like I see you looking down and think, lock in. I see like you're
So
looking.
I write in too.
All right, you go right after. Just lock in.
Oh,
Give
okay.
this a all,
All right,
right?
sir.
Okay. Remember the example I gave you with the book? Watch this, right?
Yes, sir.
Each page is a what shape? Each page is a what?
Each a rectangle.
Right. And there's a bunch of rectangles stacked up on each other to make a cuboid, yeah?
Yes, sir.
Okay. And by me stacking a bunch of pages together, it creates a third dimension, which is height, right? So what I'm trying to say here, right, Darius, is that think of the same example I gave you with the knife, right? A knife. And you could make a bunch of slices, and each slice would be a what? What shape?
A trapezoidal shape.
Right. So I have a question then. What would be the height to the 1.2 or 8.72?
8.72.
I catch you. No, not 8.72. To the 1.2. Because if you make a bunch of slices, right? If you make a bunch of thin slices, that would cover a distance of to the 1.2. The to the 1.2 is how much? You can think of it like the amount of flat trapezoids you have. Let me see if I can explain it to you in a different way. Imagine if this was a book, right, Darius? It's not a book, right?
Yes, sir. Right.
Then you'd just keep stacking
Oh, okay. Right.
a bunch of trapezoids
Yeah.
until you had a height of what?
31.2.
Exactly, right? Right. So you could
Okay,
have,
so like basically the part where you're cutting is like where it's stacking from.
yes. So
Okay,
like
sir.
I stack in a bunch of these.
Yeah.
Right. So they want me to figure out the area of the shaded cross section on the trapezoidal prism. That's not hard. We can figure that out. So Darius, to do that, tell me first, what's the volume?
Volume would be the area by the height, the cross-sectional area
Right, by the height.
multiplied by the height.
Here what they want me to figure out. They want us to figure out the area of the cross section. This is what they want us to figure out. So if they want us to figure that out, what information do we need in that equation?
Um, we need the we need to find the area for the shape and the height.
No, hear what I'm saying, right? They want us to calculate this. This is what they actually want me to figure out. Right? They actually want us to find for this. So in any equation in maths, if you're trying to find for something, you will have one unknown. So this is the unknown. If that is the unknown,
Right.
then you should have what two other pieces of information?
The height and the answer that you're looking for.
Height and the volume.
Well,
Are you seeing any talk about the volume? Look at the question. Are they giving us the volume?
yes, sir.
All right, what's the volume?
The volume is 2,886 centimeters cubed.
Right. So we know what this is. Do we know what the height is?
The height is 31.2 centimeters.
Aaron, would you have had said the height was 8.72?
Yeah, sir.
Yeah, but now you know better, right? Let me know if you want me to explain that concept here again. It's fine if you want me to explain it back. Let me know.
Yeah, sir. I wouldn't mind if you explain it again.
All right, let's check this, right? Imagine I had a bunch of trapezoids, right? I had a bunch of trapezoids.
Yeah,
Is that two-dimensional shape or a three-dimensional shape?
two-dimensional.
If I keep stacking a bunch of trapezoids, though,
It becomes three-dimensional.
Darius, this explanation making sense for you?
Yes, sir.
Right? You can clearly see that it becoming three-dimensional, right?
Yeah,
This diagram actually kind of cool. Right. So, let me ask that question, right, Aaron?
yeah,
Any height is just formed by me stacking a bunch of trapezoids on each other.
yeah,
Right. So I want you to look at this, right? This is your trapezoid here. That's your trapezoid.
yeah.
If I want, and that's a three-dimensional or two-dimensional shape.
That's two-dimensional.
If I keep stacking it upon each other,
It'll get three-dimensional.
I don't know if you see where I'm going with this.
I kind of see it, sir.
What dimension are we creating here?
A three-dimensional.
No. Yeah, we're creating a two-dimension, right? And that dimension is depth or height. And what is that? What is that depth we're creating? Or height?
The heights, sir.
Watch. Wait, so let me just continue this thing. Right. That actually look kind of cool. Yeah. So Darius and Aaron, I had a bunch of flat trapezoids, right? And I stacked them on each other. It created it created a two-dimension where over here, over here,
Underneath, sir.
underneath, right? In other words, it created a height, a two-dimension.
Right.
Does that make sense?
Yeah.
Yes, sir.
Do you all understand why I'm saying that the height is 1.2.
Yes, sir. I get it now.
So the height is just where you get from stacking the two-dimensional shapes. Like, here and watch, like this book over here, right? This book over here.
Yeah. Normally, if you like turn it vertical, you will say, oh, that's it.
Yeah, like if I turn it vertically, they'll be like, oh, watch.
But you can't get purpose.
It's looking a bit funky.
Yeah, can I be? It's not.
But watch. Watch. Can we see that this is the height, guys?
We look at
Yes, sir.
the technical brand perspective, then you could kind of see that. Right. They kind of get nice. Can I see an building?
And it's drawing real tough. Okay, yeah, guys. Can you see that this is actually the quote-unquote height that we're talking about?
Yes, sir.
Yes, sir.
Yes, sir.
And that is what you get by stacking a bunch of two-dimensional shapes on top of each other. Great. I'm happy that we understand this. I gotta take a picture. This is kind of cool. Looking real cool. Yeah, all right. So let me run through a couple hypotheticals, right, Aaron? Let me see if you really understand this. I'm gonna come up with that crazy shape here. Crazy shape over here, right? I don't see XC could do this, but like um all right, guys. What would you all say the height is?
Um, I want to
The
say underneath, sir. Like
This, right?
here
Right.
on the, yeah, there.
Because imagine if you had a bunch of two-dimensional shapes of this, you would have to take it and you would have to keep stacking. You'd have to keep stacking. And that would create this,
Until you get to the other end.
yeah. And that would create this third dimension over here. That makes sense?
Yes, sir.
yes, sir.
Okay. Happy to hear we understand this. So my volume, I already know what my volume is, right? So Darius, what's my volume?
2,886.
Right? And that's equal to my cross-sectional area. I don't know what that is. What's my height?
Right. The height is 31.2.
So what would I need to do on both sides if I want to find for C?
You would had a you would have to divide it 31.2 on both sides.
Right. So I would cancel off, just leaving with
And then it'll be 2,806 divided by 31.2. And
I
you'll
got
get
92.5.
exactly 92.5.
Yeah.
Yes, sir.
Great. And that'll be centimeters squared, right? Because you're finding for cross-sectional area.
Yes, sir.
Right. So, the good thing I decided to do this last question because a question could come like this in the exam. I know they might put this for height. Now you know better. Now you know better, right? The
Yes,
height
sir.
is by you stacking a two-dimensional shape on top of each other. Yeah. Let's surely understand this. I'm looking at all you know. I'm looking at all you. Oh God, I can't see all you without my glasses. Let me put up my glasses. Yeah, I can see all you. Yeah, I can't see without my glasses. It's bad, real bad.
See,
Yeah, what's the one say he looking at all you, but he can't see all you. Oh, that's hilarious. That's hilarious. All right. So, Darius, welcome with part two.
The cuboid-shaped gold bar shown below has the same volume as the trapezoidal prism-shaped gold bar displayed at A. Calculate the height h of the cuboid-shaped gold bar.
Right. So, guys, let's try to understand this thing, right? They are saying it has the same what?
The
Volume.
same volume.
Same volume, right? What was the volume?
2,886.
2,886.
Right. So 2,886. And that's equal to the volume on this, right? Now, what kind of shape is this?
A cuboid.
Cuboid.
Let me see how good you understand the concept, right? Can we all understand, right? If you have a knife or something, right?
Right.
And you cut slices. So imagine a stick of butter, right? No matter where you cut it, wouldn't you see a square? Well, it's not really a square, but like, wouldn't you see a quadrilateral?
Yeah, sir.
Okay.
Like, I think everybody can see that watch.
Right.
Right, so this is technically a prism. So tell me, guys, what would be the height? Like, actually, when I say height, right, I'm talking about cross-sectional area by height. What would really be the height?
30.6.
30.6, right? Yes, 30.6. Great. Glad to see we understand that concept. Now, to find the volume of a cuboid, and we know it's just length by width by height, or length.
Yeah.
Yes, sir.
So that would just be h multiplied by 30.6 multiplied by 8.2.
Right.
So work out the product there and let me know what you get.
When you multiply the 30.6 and 8.2, you get 250.92.
Yeah, I got that, sir.
And then the 2,886 divided by 250.92,
I got 11.50.
111.34 is what I get. Wait,
What?
no, I must have that zero. Wait, I must have that zero. Hold on. Yeah, 11.50.
Right. Right, and since we're finding height, right, it's going to be centimeters, right?
Right.
Are we okay with?
Cube. Oh no, because it's not volume.
Let me know if you guys okay with this question.
Yes, sir, I'm okay with it.
Right. Darius, part B now, get a read from her.
The trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. Calculate for each sphere of gold its I radius.
All right, so first things first. They say any trapezoidal gold bar, right? This gold bar, right? I'm melting it down into how much spheres?
6 identical spheres.
6, right? 6. So how would I find the volume for one of these spheres?
You would have to divide it by 6.
Right. Makes sense, right? And let me explain why we want to do that. Because for Darius, right, they're saying calculate for each, right? Each sphere of gold, its radius. And they are giving us formula for volume. Think to yourself, Darius. If I want R, R needs to be the only unknown in this equation. So I'll need to find for what?
The volume of one sphere.
Exactly. Right? So volume of one sphere that would be equal to 2886 divided by
Divided by 6. You'll get 481.
exactly 481.
Yes, sir.
Okay, we're good. And that'll be centimeters cubed, right?
Yes, sir.
Great. So we know what the volume is, right? So did it tell us use pi as anything specific? Yeah, 22/7. So we know that the volume for one is 481, right? So we're gonna say 481, right, is equal to 4/3 multiplied by 22/7 r cubed, yeah?
Yes, sir.
Now here we're gonna do, right? 4/3 by 22/7.
Um, 88/21.
88/21, right?
Yes, sir.
Later,
Well, if you want the decimal, is 4.19.
let me check something else. Okay, yeah, no. Did I lose it? Oh no, here it is. Has to be this paper. Right. So 88/21, yeah? Yeah,
Yes,
guys?
sir.
Now, Aaron, can we use the trick I just showed you?
Yeah, sir.
So we're gonna multiply both sides by,
21
21 over
over
88.
80.
right? And so r cubed is just going to be equal to 481 multiplied by 21/88. Right? And what would you get?
I got 114.78.
So here what? We should just find the cube root of that whole thing one time. Right? So to find for r would just be equal to the cube root of that entire thing. So plug into the calculator and let me know when you get some.
So I forgot how
4
is access
points.
how is access cube root on your Casio?
Press shift square root.
No.
You
So I
should get
get 4.86
yeah,
rounded off.
right 4.86 and we
Yeah, I
said
got 4.86 too.
I'm curious to see how we do it. I New Zealand totally live. Okay, we do like this. What we supposed to use by 22/7. Oof.
Then I got Stephen.
They get the same answer. They get the same answer, so it's fine. 4.86. Same answer. Right, let me know if I understand this.
Yeah, so
Yes,
I get
sir.
it.
You would right now in part 2. I don't know what to find for.
Surface area.
Right? Super area. We have more. Right, so this one really easy. They give us the formula, right? So the surface area A is just equal to 4 pi r squared. Do we know what r is?
4.86.
Right? Plug into your calculator, I'm gonna win that. Now, ideally, you would want to use the exact answer, right? Ideally, you'd want to use that. And if I do use that, I get, I
I
guess,
get
what are you all getting?
I think I do something wrong here.
Oh, Darius, I just use the exact value. Like, tell me what you get. You get 61 point something?
No, I get 200 and something.
Nah, something wrong. Unless I,
Yeah, sir, I got
it's a,
96.993.
oh,
I
Yeah,
get a
so
three.
I get 296.93. Yeah.
I realized what I do, right? I forgot to square it. Yeah. When you square it,
Okay.
4 by
Okay.
22 over 7, right? And that would just be, that would be the 481. I find the near exact answer. Yeah, only get the answer.
Yes,
Yes,
sir.
sir.
So if you only round it off all the answer, the two decimal places again.
296.
296.93.
Okay, and if I use the exact value, I get 296.92. This is using the exact value. My advice is, I don't think they penalize you, but the best practice is to use the exact answer, the exact values, especially in multi-step questions. Right, so that'll be centimeters squared. I don't think this penalizes us for that UV, like using exact values.
Yeah, I don't do that.
I don't do that.
That's just when I say, well,
Yeah, but just common practice. Try to use the exact answers. But yeah, you all got 296.9 something.
Yes, sir.
93.
Okay, good. Right, so Darius, last question. Read.
Mass to the nearest kilogram given that the density of gold is 19.3 grams per centimeters cubed.
Ah, density at goal, right? So
Yes,
density,
sir.
mass over volume. If I want to find for mass, what would I have to do on both sides?
You'd have to multiply by volume on both sides.
Right. So mass will be equal to density.
Multiply by volume.
And if anybody is confused, watch this, right? If I multiply both sides by volume, what's going to happen when the volume in the denominator and the volume in the numerator? Here, what's going to happen there? Our
They'll
volume,
cancel off.
The two volumes are gonna cancel out, sir, and leaving only mass.
exactly, right? Now, the density is 19.3, right?
Yeah.
Pay attention to the units, so that's grams per cm cube. And I'm multiplying that by the volume. Right? And remember, we find out for a sphere, one sphere, each sphere. So the volume for one sphere was 481, right?
Mm-hmm.
So was 19.3 by 481?
I got
9,283.
9,283.3.
9,283.3.
Yeah.
Yes, sir.
And if I got the answer here. Yeah, we got the same answer. Agreed. Right? And Guys, pay special attention to the units, please, because density here is given in grams per centimeter cube, right? And we are multiplying
Right.
volume. Volume is centimeter cube. The centimeter cube and the centimeter cube cancel off to give us grams. So our final answer is in grams. But
Right.
we want the answer to the nearest kilogram, right? Kilogram. So first things first, how do I go from grams to kilograms?
Yeah, I don't know how much grams would have in 1 kilogram.
How much grams would I have in 1 kilogram?
1,000.
1,000, right? 1,000. So you know what we have to do? You would have to take this and divide it by 1,000, right? So the mass would be equal to 1, 2, 3. That would be 9.
9.2833 kilograms.
When I said to the nearest kilogram, right?
Yes, sir.
So the 9 is in the kilograms position. What's the number after 9?
2.
2. So since 2 is less than 5, you're going to round down. So that should be 9 kg. Let me know if you understand this.
Yes, sir.
What about the rest of you guys? Does it make sense?
Yes, I get it.
Okay. Right. So that's it for area and volume. I most likely believe that this year they're going to bring a circle question. They like to bring circles. Something with circles. For sure. Right? So now you should know that the circumference for a circle is 2 pi r, right? You should know that. If you want to
Right.
find length of an arc, it's the circumference 2 pi r multiplied by theta over 360. You should know that the area of a circle is pi r squared, and the area of a sector, which is just a fraction of a whole circle, is pi r squared by theta over 360. You should know these things by now. Well, for the exam. And if you're dealing with a prism, you should know that the volume is the cross-sectional area by the height. So all of these things are things you need to know for the exam. Right? Great. So guys, take a 15 minutes break. You know what? Come back at 6:15. Come back at 6:15. We're going to do transformations and then measurements. Yeah. Finishing everything today. So see you guys at 6:15. All right, guys, I'll be back. Let me know, guys. Ready for action?
Yes.
Say no more. I will be finishing at 7 o'clock. Right? The only thing we will not be able to finish today is measurements, but I want to go spend time with my family and thing, and I'm sure they want to spend time with other family too. You know, it's like, oh yes. So let me jump straight into it. Let me not waste no time. So we're going to be looking at transformations, right? I have a bunch of questions already here. So under transformations, let me show you the main types. The main types are a translation. Now, what exactly is a translation? A translation is when you slide a shape to the right and then to the left. What's it? Is when you imagine you have a shape, right? Imagine you have a shape here, a circle, for instance. A translation would mean that I'm taking the shape and I'm moving it left or right, and then up or down. That's all a translation is. You're sliding a shape. And it's given by a column vector xy. Right? So depending on what x is, you're going to move the shape either left or right. And depending on what y is, you're going to move the shape up or down. So x would correspond to a left or right movement. Right? And y would correspond to an up or down movement. Okay, the next type of transformation is a reflection. Do any of you guys know what a reflection is? A reflection.
Yes, sir.
Like a mirror.
Yes. So if I imagine if I had let me just say I had this shape over here. If I reflect that shape on the other side, it's going to look like this. Do we understand that?
Yes, sir.
Okay, now when you're dealing with a reflection, you need to say that let me just say object. You need to specify what the axis, right, of symmetry is. You need to specify what the axis of symmetry is. So let me give you an example. Let's just say we had the shape A and we had the shape A prime, right? So this is the object, right? And this is the image. And let's just say that this line was, by the way, guys, if I have a line here, would that be any form y is equal to something or x is equal to something? It is a vertical line. So would it be y is equal to something or x is equal to something? I'm not hearing anybody, right? But remember, if it's a vertical line, then it will be uniform. X is equal to something. Let's just say with x equal to 1.
Um,
Try to remember why. Imagine this is the Cartesian plane, right? Y and x. Wouldn't this be a vertical line passing through x is equal to 1?
yes, sir.
Yeah, so when you're dealing with a reflection, you need to write statements like this. So object A is mapped onto A prime via a reflection about the line x is equal to 1. So when you're dealing with reflections, you need to be able to identify the equation of lines, right? Equation of lines. The ones that will typically come will be in the form x is equal to n, y is equal to n, right? Y is equal to x, and y is equal to minus x. X is equal to n looks like a vertical line. Y is equal to n looks like a horizontal line. Y is equal to x is a perfect diagonal in that direction. y is equal to negative x is a perfect diagonal in the opposite direction. That's what you need to be familiar with for reflections. Next one, an enlargement. When you hear the word enlargement, what do you think of? Enlargement, bigger or smaller, what do you think of? Okay.
Big.
Think of things getting larger, sir.
Exactly, right? So imagine you had this rectangle over here, right? Imagine you had a rectangle, cool. Can you guys see that I made it bigger?
Yes, sir.
How much times bigger?
Um,
So that brings me on to a very good point for enlargement. So enlargement, you need to state the center of enlargement. You need to state the center of enlargement. And you need to state the scale factor key. Scale factor key. So let's just say that this is, let's just call this key, and let's just call this key prime. Anytime you see prime, just know we're talking about the image, right? K is the object. If we want to find the scale factor key, it's just simply the image length all over the object length. So guys, what is the length over here? How much blocks is that?
1 block.
1 block. How much blocks here?
2 blocks.
So it looks like a scale factor of what? Image length will be 2 and the object length will be 1. What's the scale factor? I didn't hear anybody but 1 to go into 2 times. Factor is 2. And additionally, watch this. Over here, this is 2 blocks. Right? And this is 4 blocks. Right? How much times bigger does it get?
2 times.
Right? So we understand that.
Yes, sir.
Next thing you need to be able to do, you need to be able to find the center of enlargement. To do that, you are going to take your ruler. So wait, let me just put some points down over here. Put a point in red and in blue. Put this point in red. Put this point in green. You need to take your ruler and line it up with corresponding points. Right? And you need to look at where they're intersecting. You'll see what I mean very, very shortly. All right, guys. So I'm going to take my ruler and I'm going to line it up by the corresponding points, and I'm going to draw a line. Right?
Yes, sir.
That's what I'm going to do. Now you only need to do this for two points, because you're looking for a point of intersection. That's what you're looking for. And I will tell you the center of enlargement. Tell me, guys, are we seeing like a common point of intersection there?
Yes, sir.
Yeah, so on your graph, you would do this, right? And whatever point you get, you'd call that the center of enlargement. That's it. So this would be the center of enlargement. Great. Happy to hear we understand that. So that's enlargement. So for under enlargement, you need to state, right, the scale factor, and you need to state the center of enlargement to get your full marks. All right. Now let's move on to rotation. Now, if we're talking about rotation, these are the things you need to know. You need to know the center of rotation. Right? And you need to know how much you're rotated by. So you need to know the degrees as well as direction. Degrees and direction. So let me give you an example. Let's just call this O. Let's just call this O prime. So guys, in this instance, you would say that the object O was mapped onto the image via a what?
Rotation.
Right, so let me show you what we would say, right? Like the full thing. And how much degrees does that look like? That looks like 90 degrees, right? 90 degrees clockwise or anti-clockwise?
Clockwise.
Right, 90 degrees clockwise. So you would say O is mapped onto O prime via a 90-degree rotation clockwise rotation about the origin. That's what you would say. Right? Because as you will see, the rotation happens about the origin. So I would say O is mapped onto O prime via a 90 degrees clockwise rotation about the origin. Right? And just like that, that's all of the transformations. So now we can start passing our questions. Right? Now, when you're dealing with rotations, you need to be able to figure out the center of rotation. And it's not very straightforward. To do it, you actually have to connect corresponding points and find the perpendicular bisector. And you need to do this repeatedly. Right? And wherever they intersect, that would tell you the center of rotation. So let's get straight into the questions, shall we? Right. All right, so there we go, right? I'll have the answers here so I can just PT in one thing to save some time. Right, so in the first question, they're asking us to describe fully a single transformation that maps shape P onto shape Q, right? Shape P onto shape Q. Right, so guys, can we see that this is shape P?
Yes, sir.
Yes, sir.
Guys, does that look like a reflection, rotation, and enlargement? What does that look like?
That looks like a rotation.
Yeah, that's a rotation. So let me show you how we're going to do this, right? So I'm going to connect corresponding points or vertices, and I'm going to find the perpendicular bisector. Let me show you guys how we're going to do that. So you see that point, right? That point and this point, they are corresponding, right? So I'm going to take a ruler, right? And I'm going to connect those 2 points. Right? Okay, cool. And now I'm going to find the perpendicular bisector. Now, my biggest hack here would be to use your right angle triangle from your protractor, from your geometry pan. Does everybody know what a 90-degree angle triangle looks like? Yes or no?
Yes, sir.
Yes, sir.
So I guys, why you gonna go through all that trouble find any bisector by hand? Let me show you a hack. So 90-degree angle triangle from geometry on 1 second. Okay, give me a second. It downloaded. Nice. Okay, word. So let me give all you my advice, right? This is my 2 cents on the matter. Perpendicular bisector. I'm gonna just share on screen. Yeah. Right. So perpendicular bisector means that you're gonna cut the line in half and you're gonna draw a line 90 degrees to the center point. So somebody tell me what is the length of this? The length of the line I just drew. What's the length of that line?
Um, what equals MS
6.557.
plus C?
That look like 6.7, right? Where's half of 6.7?
6.75.
No, half of 6.7 would be 6.7 divided by 2. 6.7 divided by 2 is
3.35, sir.
3.35 would be somewhere over here. So 3.3, that would be over here. So what I would advise you to do, shortcut, take your ruler, find the half mark, then take your 90-degree angle triangle, right? You're going to take a 90-degree angle triangle and you're going to line it up, right? Right. Do this. Right, that's your perpendicular bisector there. Cool. Right. Okay, word. That's your perpendicular bisector there. Now you need to do it for another corresponding set of points. So just by looking at this, I'm seeing that this point and this point, right? Those points are corresponding points. So in other words, before and after the transformation, those are the same points. I'm going to connect those two to each other. I'll measure the length and find the half mark. Guys, that approximately looks like 5, right? 5. So half of 5 is 2.5. So I'll put it over here. So like right here. Right, and the perpendicular bisector for that. Wait. I got rid of it. Okay, give me a second. Do this one quickly. Now, this is one of the weird questions, but I'm going to show you where the intersection is. You can already see the intersection, by the way. Should already be able to see it. So here what I'm saying, right, guys? I'm saying that if you have a rotation, right? Where did it go? Where is it? Yeah. I'm saying that if you have a rotation, right, there are two things you need to figure out. You need to figure out the center of rotation as well as the angle. If you need to figure out the center of rotation, you're going to connect corresponding points, find the perpendicular bisector, and you need to do this for at least 2 points. Wherever the perpendicular bisectors intersect, that's going to tell you the center of rotation. I should probably make this red, right? So guys, can we see that? Okay, so we have a perpendicular bisector here, and we have one over here. Where are they intersecting, guys? Watch, look at that again. Where are they intersecting? Can we see that they're intersecting over here?
Yes, sir.
Right. So that is my center of rotation. Could somebody read off that point for me? Wait, let me just zoom out, and you should be able to. What is our point?
I think it was 3.35, sir.
Nah, that's 7, 7.
7, 7.
Yeah, 7.
Oh.
Right, 7, comma 7. Right, and let me show you what I'm gonna do. So like, guys, if you also look at this, it looks like a rotation of how much degrees?
180.
Yeah, it's 180 degrees. Right? And let me see how I could show you that. So if I connect this point here to my center of rotation, and I connect this point to my center of rotation, what is the angle here?
180.
180.
Right. So therefore, I would say, it's here, I would say that shape P is mapped onto Q by a rotation of 180 degrees clockwise about the center of rotation 7, 7. Is there anybody that didn't understand that at all?
No, sir.
No, sir.
All right, good. Next one. P onto R. P onto R. So guys, this looks like a what? Look at P and
A
look at,
reflection.
right. Now, for a reflection to work, it needs to be equidistant. So you can't just say that is a reflection about the y-axis. Who would say that? Is there anybody here that would say that is a reflection about the y-axis? Okay, based on the silence, that's good. The answer would be that it's a reflection about the line x is equal to. This line passes through what on the x-axis?
1, sir.
1.
So this is a reflection about the line x is equal to 1. Now you'd have heard me use words like equidistance and whatnot. Guys, if I use this line, right, can we see that the distance, the object and image distance is the same on either side?
Yes, sir.
Yes,
Yes,
sir.
sir.
So that's how I know that that's the axis of symmetry, right? So I would say that shape P is mapped onto shape R by a reflection about the line x is equal to 1. Do you guys understand that or not?
Yes, sir.
Yes, sir.
Yeah.
All right, I just draw this a little thicker. Not real thick. Wow. Hello, we can all equal night tonight?
I don't know.
No, sir.
You know, like the culture now. Can try a lot and I wake the whole night out. Like cook food and, you know.
Yeah, but sir, I on the grind. I've been waking up at 4:30 for the past few days. So
I know what that feels like. All right. P onto S now. P onto S, guys. What does that look like? If this is P, right?
Enlargement.
Right. For enlargement, what are the two things you need to state?
How much it enlarged by?
So you need to state the scale factor K, and what else? That's what C. Scroll up back, remind me. 32 things you need to say.
The scale factor.
At
And,
the center of enlargement.
and to find the center of enlargement, you're going to connect corresponding points and see where they intersect at. So that's what you're going to do over here. So, guys, if I select this point over here, do you understand why I'm selecting this point as well?
Yes, sir.
All right. Let me just say I select this point over here. I would select this point over here. Truth be told, you just need two pairs of corresponding points. So let me just connect these two here. Right. Are we seeing a point of intersection?
Yes, sir.
Yes, sir.
The point of intersection.
7-11.
7-11.
Imagine if it was 9-11. 7, 11. So therefore, someone try to say the sentence. I would say that shape P is mapped onto shape S via a what? A what? Someone. Via a?
Enlargement of 7-11.
No. Nah, you wouldn't say that. We still need to figure out the scale factor, right? So to figure out the scale factor, I would implore you to look at one of the lengths. So what's the length here?
2 and S is 4.
Right? That's 1 and this is 2. Right? Another example is this is 2 and this is 4. So it looked as though it got how much times bigger?
Plus the amount of P.
Right. So guys, we would say that shape P is mapped onto shape S via an enlargement, right? With a scale factor of 2 about the center of enlargement 7-11. That's what I would say. So the sentence you would say is over here. I would say that shape P is mapped onto shape S by an enlargement of scale factor 2 with a center of enlargement 7-11. Do we understand that?
Yes, sir.
Yes, sir.
Okay, good. Part B now. On the grid provided on page 10, draw the image of shape P after a translation by the vector -2, 3. Label this image C. Now, guys, this is a translation, right? So the first value here tells us to move in what direction?
Anti-clockwise.
Left.
Not anti-clockwise. Anytime you have a translation, you're moving the object left, right, and then up or down. So X, Y. So X would correspond to a horizontal movement. Right? And Y would correspond to what kind of movement?
Vertical.
Vertical, yes. Now, guys, if it's negative, right? Do you think it's to the left or to the right?
To the left.
Right, -2 is to the left. And if you are confused, think about the shape, think about how you would label a graph, right? Wouldn't all the negative values be over here to the left?
Yes, sir.
Yeah, so -2 means you're moving 2 spaces to the left. And 3, you think that would be 3 spaces in one direction?
3 spaces up.
Right. So here we're gonna do, right? We're gonna take shape P, right? And it's -2, 3. Okay. Right, so I just use this diagram here. So guys, here we're gonna do, we're gonna take a random point. So I'm gonna select this point, right? See that point there? I'm gonna select it and I'm gonna move that point. So the translation was -2, 3. So I'm gonna take this point and I'm gonna move how much spaces?
-2 down. I mean -2 across and 3 up.
Right, so 2 to the left, right? Yeah,
Yeah.
to the left.
Yeah.
I would end up over there, right? I mean, if you understand that. So I just moved 2 to the left. And how much spaces are gonna move up or down now?
You're gonna move 3
And
spaces
move
up.
3 up.
So I would end up over here, right?
Yeah.
Okay, great. So here what? I just shifted this point. Now I can repopulate the points based on the general location. So this point over here is two spaces away from this point. So I would say that's, the point is over here, right? This point is one space to the left of this point. So I'll say over here. Let's see what's going with this,
Yes, sir.
right? And then two spaces, right? And now I just connect all of those points. So when you're doing a translation, I would advise you just shift one point and then figure out all the other points from there based on the general location. And they wanted me to call that T. So there it is, call it T. Do we understand the translation?
Yes, sir.
Yes, sir.
Word. So let me do another question, shall we? Right, so they want us to figure out how triangle X is mapped onto triangle Y. So they're saying triangle X is mapped onto triangle Y by a reflection. State the equation of the mirror line. So we're looking at X and Y, right? X and Y. X and Y. If you look at X and Y, that looks like a reflection about what line? Oh, tell me. It looks like a reflection about what? X and Y.
On the Y line.
On the Y line.
The
No,
X, no?
that'd be the X line. If it was the Y line, it'll look like this,
Oh,
right? If you notice, this is the X axis, right? So
yeah.
check it out. That makes sense?
Yeah.
Right. So you could have said, let me tell you the possible answers you could have said, right? So you could have said X axis, or you could have said about the line Y is equal to 0. Those are two answers that are acceptable, right? So but they wanted you to state the equation. So you had how to say Y is equal to 0. If you said the X axis, it would not be enough. And let me try to explain why that is. Who here doesn't understand why is Y is equal to 0? Aaron, do you know why is Y is equal to 0?
Yes, sir.
Okay, let me just explain it to those that don't understand, right? Guys, let's just say I had this line here, right? That blue line is passing through what?
The y-axis.
What's on the y-axis?
6.
6.
So what would I say the equation of that line is?
Y is
Y is
equal to
equal to
6.
6.
So if I keep shifting the line down, this will be Y is equal to 4. Y is equal to 2. Y is equal to 1. What do you think this could be?
Y is equal to 0.
Y is equal to 0.
Are we okay with it?
Yes, sir.
Yes, sir.
Okay, would. So that was the answer for that. Right? Describe fully the transformation which maps X onto Z. X onto Z. What do you all think that looks like? X onto Z.
A rotation, sir.
Yeah, guys, let's see now being a rotation.
Yeah.
Yes, sir.
So
Yes, sir.
so for a rotation, remember the two things I need.
Center of enlargement and the scale factor.
I ain't talking about enlargement. I'm talking about rotation.
Oh.
Yeah. And enlargement is when you're making a shape bigger, right? Can we both see that you're not making a shape bigger, you're just rotating it? Can we see that?
Yes, sir.
Yeah.
Yeah. So for rotation, the things that you need is the center of rotation, not to be confused with center of enlargement. And you need to figure out the degrees. So like how much did you rotate it? You need to figure out the degrees and you need to figure out the direction. So to figure out the center of rotation, we need to connect corresponding points and do the perpendicular bisector. That's what we need to do. So guys, I'm going to select this point. The corresponding point for that after rotation will be this point. Who here is confused by that? Tell me, who here is confused by that? Everybody understand this? At least tell me if you understand it.
Yeah.
I think I get it.
So do you understand that? Okay, what's right? If I take the shape, right? Take the shape. What? Somebody in good notes needs to be fired. Like, I don't know what they do about it. Yeah. Aaron, watch this, right? Imagine how that shape there, right? And you see that point I drew over here is the same, it corresponds to this point over here.
Yeah, so I can see that.
Okay, good. So guys, I'm going to connect those 2 points like so. Right? And that length is what? That length is 6 points. Probably connect 6.8. Yeah? What's half of 6 point?
Yeah,
3.4.
3.4.
So that would go over here. Right? Right? And the line perpendicular to that would be right here. Let me know if you understand that. Now, in the exam, take away to take a right angle triangle, right? And you will take a right angle triangle and you will line it up and you will draw a line. But do we understand that that's the perpendicular bisector there?
yeah.
Yeah.
So
Okay, so now we need to repeat the same process, right? But with a different line. So I'm going to use this point and this point next. I'm going to connect those 2 points. And I need to draw the perpendicular bisector. First things first, what is the length of that line? Okay, tell me what the length is.
2.4.
We have a 2.4. How about 2.4 is?
1.2.
Right. 1.2 would be over here. Right? And the right angle seems to be over there. Right. Okay. Tell me guys, where are both of the perpendicular bisectors intersecting at? Where are the perpendicular bisectors intersecting at? So this is the perpendicular bisector here, and this is the other one. Where are they intersecting at?
0, 0.
0, 0, right? So
Right.
that is your center rotation. And if you want to see it better, watch. It looked like it was rotated how much degrees?
90.
90 degrees in what direction?
Anti-clockwise.
Left.
Left is not direction.
anti-clockwise.
Or anti-clockwise.
Right. Anti-clockwise. So guys, I would say that shape X is mapped onto shape Z via a rotation of 90 degrees anti-clockwise about the center of rotation 0, 0, or about the origin. That is what I would say. So I have it over here, right? Triangle X is mapped onto triangle Z by a rotation of 90 degrees anti-clockwise about the origin. Part 3 now. On the diagram on page 10, translate triangle Y using a vector -7, 1. So guys, -7 means I'm going to move how much spaces in what direction?
-7 places to the left.
I wouldn't say -7 spaces to the left. You would say 7 spaces to the left. No, the negative there means I go into the left. So it's just 7 spaces to the left. Not 7 spaces to the left. 7 spaces to the left. Right. And this one, what does this one mean?
One space up.
Right. 1 space up. So 7 spaces to the left and 1 space up. Transit triangle Y. So Y, I think it was -7, 1. Verify that. Yeah, -7, 1. So I'm going to take one of the points here, right? And I'm going to move it 7 spaces to my left. So count with me, right? So 1, 2, 3, 4, 5, 6, 7. Okay. Do you understand how I did that?
Yes, sir.
Yeah.
And now we're going to move 1 space up. So 1 space up would be over here. So now I just have to label all my other points around this point here. So this is the point here, right? So if that's my point over there, and I move this point, then this point here would be 1, 2, 3, 4, 5, 6 spaces, right? 6 spaces to the right. All right, so 1, 2, 3, 4, 5, 6 over here, right? Then that would be here. Are you guys able to follow along? I wonder if you understand how I did that.
Yes, sir.
Okay, good. And what do they want us to call that? Label this image V. All right, so we'll label it V. V for victory. Right. On the diagram on page 10, enlarge triangle X about the center C, 0, 0, and scale factor half. So guys, if the scale factor is a half, are we making the shape bigger or smaller?
Smaller.
Yes, smaller, right? So let me show you guys how we'll attack that question. So we want to quote unquote enlarge triangle X, right? About the center is 0, 0. So let me show you what I want to do, right? So this is 0, 0 here. I'm going to draw lines connecting 0, 0 to all of the vertices. So bear with me, right? So I just put on all the vertices. Now I'm going to take my ruler. I'm going to line it up. Like so. It's right. So here is what we're going to do, right? Here's what we're going to do. Our scale factor is what? Remind me, what is our scale factor?
A half.
A half. So if this length here is 1, 2, 3, 4, 5, 6, and I half that, what will it now become?
3.
3.
3.
Right? So 3, okay. Right. Did you guys understand how I just did that?
Yes, sir.
Yes, sir.
Right. And if they wanted it bigger, like 1, 2, 3, 4, 5, 6, you need to follow the same concept. So, like, say they wanted us to scale it up, you would just follow the exact same concept. Let me know if you guys understand that.
Yes, sir.
Yes, sir.
Okay, weird. Weird. So, yeah, guys, that is it for transformations. So, I send this document to you guys containing a bunch of other transformation questions. The only thing we need to look at is construction. And I will try to do that sometime before the exam, I promise. Right? The transformation questions is usually how much marks, boy? How much marks is it? Let's see.
So we're still going to do the other live.
Yeah, I'm gonna do that.
Okay.
5 marks. Uh, well, would see what I can do for the construction, but yeah, we essentially finished the whole syllabus without rushing anything. It's a crazy degree, right? So yeah, guys, I hope all you enjoy all your old years, right? Don't do anything illegal, and yeah, guys, it was a pleasure meeting some of you guys for the very first time. I wish you all your real success. But most likely I'll see you guys on another session. Because again, I want to finish construction. So yeah, guys. Have a happy new year.
You too.
Thanks, sir.
You too,
Same to
sir.
Same to
you.
you, sir.
Thank you. Later, guys.